operation teams, they go ahead, they deploy this, they go ahead, they deploy this, and things go. This is when you will be hearing. This is when you will be hearing support complaints from your customer support. They are receiving calls that the application is not working as intended, performance is not good, performance is not good.
Asim,
Something.
sorry to interrupt, but
Sorry to interrupt, but I think
there's a technical issue regarding the sound right now. Owen, are we looking into it? We will let you know. Maybe you can start from traditional development and operation. Sorry about that.
No worries. So you want me to start again, or?
Yeah, if you can.
Okay. Should I do it now, or waiting for the sounds to be fixed?
We'll wait for the sound to be fixed. Oh, they are telling us there's a bit of echo.
Okay.
Guys who are watching the live stream, I will mute my mic. Let me know if there's still echo.
Are we good?
Okay, you can start, Wasim. It's good.
All right. Okay. Thanks. All right. So let me start again on this slide. So what goes on within a traditional development team is their development team, they build, they test, they package the application, and they ship everything to the operation team. So the operations team, the main aim is to have this ready for customers to use. So they deploy this so that customer can go ahead and use it. But what goes on between them is sometimes they are missing in terms of communication. Instructions are not clear. So this is when we have the wall of confusion. So what happens is sometimes when developers are using a latest feature and communications are not fluent to the operations team, when this goes on, the application would not work as intended in production, and customer support would be receiving complaints from customers stating that the performance is not good or the application is not behaving as intended. One good example might be that developers are using a resource, as an example, let's say service bus within the whole architecture, and operations team wasn't told of this. So what happens is the application is now relying on something which does not exist in production, and nothing works correctly. So this is when we want to really look into DevOps piece, which really brings and bridges the gap between these two. Security, a cloud advocate of manager at Microsoft. The DevOps is the union of people, process, and product to enable the continuous delivery of value to our end user. So in here, people are mainly the developers, the operations team. Process is what you do from the beginning to the end, meaning from developers building the code, QA testing the code, for them packaging everything, to operations team deploying the code to their resources, whether on-prem or in the cloud. And the product here itself is the product, because you want to bring the product together as part of the whole process and not something which sits as an artifact on a repo somewhere. The main aim why you want this to be achieved is because you want to bring value to your product, to your end user. Without end user, there's no product and your business ain't gonna flourish. Some more quotes about this. So as I mentioned, right, so development is operations collaboration with development. We want them to collaborate so that, everything works together side by side. DevOps is also treating your infrastructure as code. So as I mentioned, if developers are using a new feature as a service bus, but operations are not told anything about it, so nothing would work. So you want to make sure your infrastructure is being checked in as your code within your repo. So whoever's working on the branch or on the forking your repo or anything, they are making sure they are running the latest infrastructure as well for your application. DevOps is also using automation. No one wants to do these boring tasks again and again. Developers are humans too, QA are humans too. They might be missing out nice piece, meaning some recommended piece, which is testing, which is security testing and all these type of testing. So we want to make sure that we are automating the boring piece so that the machine are doing it for us, and developers are mainly focusing on what they do best, which is writing code. DevOps is also a small deployment, because when you think about the agile concept, we want to make sure that we deploy, we listen to feedback from our customers, and then we go back to the board and start again. We fix whatever was not correct, and we improve on what is good already. DevOps is also monitoring, planning, and starting over, because it's a whole in an infinite loop sort of thing. So once you're done with your deployment, you monitor your application, you plan again and start over, because we want to keep on running everything in iteration. So if we want to put this in a nice diagram, so you have this DevOps process where we all start with the planning piece, right? So we plan what to do, we do it from the develop piece. We build the application, we package it, we test it, we release it to our resource. Then once you're done, we configure it, we monitor what was deployed, and then we plan again, we start over. So this diagram is more of an Azure DevOps perspective. Azure DevOps meaning the solution itself, as you can. No, okay, so enough with all the boring stuff. Let's get some demo going. As I mentioned, we always start with some sort of boards, right? So I have two work items to user story assigned to me, but the first one is create pipeline. So let me go ahead and put this one on active. We get this one going. In here, I have my Visual Studio Code. I
Wasim, Wasim, I'm sorry. I think your mic has been muted. Can you unmute it, please?
Yep. Okay.
Okay, good now,
Perfect. Okay. So what happens here is we're pausing the .NET restore. So we are saying restore the project, and then once the restore has been done, we go ahead and build it. So let's take a look at the pipeline. It has been completed already. In here, we have different steps now. We have the restore steps, which is restoring all the dependencies, all the NuGet packages. And once this one is done, we go ahead and perform the build. Why we have it split in two is because of we want to be able to say, right, restore all dependencies for all my projects. In this case, we have only one, but if you have multiple projects in there, so it will restore all dependencies for all your projects, and then you go ahead and build it. So in here, the build is anything CS project, so it will build all the project, but you can have other scenarios as we will have later on in this demo. So at this point, we are good. If I bring back the this slide, so we have the plan good. We sort of start with the develop piece. Everything looks good. So we are almost done with the integration piece because we were able to build our application on the cloud using Azure DevOps. So the next piece we want to do now is package it, because we want to package it so that we can leverage it multiple places. You can go ahead and use it to test on a separate VM. You can use it to test your application on a locally hosted agent. So you might be using different you might be using different different machines, different ways that you can test. So what we want to do now is let's go ahead and look into the next piece, which is packaging it. So for the packagement piece, let me push this, and then we can look into the same thing together. Okay. So what we are doing now is we are saying, right, after building the application, we want to go ahead and publish it. So we want to publish it in a way that we have something that we can use further on. Same thing once again, the .NET Core CLI. We're going to be using a lot of this anyway. So we are saying publish the project that we have. Don't build it because we built it previously. That's the release configuration, and the output we want all the binaries to be at this point on this directory. And once everything is good, this is what we do next: is we sort of upload the package. So let's go back to this one. Let me compare to the previous one. If you compare to the previous one, it says artifacts, 0 artifacts. That means this build, this pipeline did not have any artifacts at that time. So what we did now is we added the publish artifact. You can see this one is 1. So the good thing out of it is on top of building the pipeline, on top of building your application, Azure DevOps will also make sure that you can download it. So I can go ahead download this on my local machine. I can go ahead and deploy this on my own without any issues. So at this point it will work. So Azure DevOps did some part of the heavy lifting for me. It built the application. I can go ahead and take this, deploy it myself. But we don't want to end there, right? So we want to get things going. Developers are humans too, so we all do errors. We all miss some of the boring piece, as I call it. So testing. This project and another branch, it has another project here. So that's the test project that I have. In here, it's asking for. So the test is look for 10 days of forecasted weather forecast, but we know it's already 5 as we had previously in the UI and the website. I know this one will fail. So let me go ahead and add this piece to the YAML. Then we can look into it, why it's building, why it's testing. So after packaging, we want to go ahead and do some testing. Let me do this, push it, and then I'll show you the demo. So what we are doing here is we are saying after packaging, after everything looks good, let's go ahead and do some testing. So we are using the .NET Core CLI once again. We are saying test it, don't build it or anything, but now use any project that has the pattern.test.cs project within our repo. So that's basically this one, as you can see, this one, the test.cs project. So it will run the test for this. So if I go ahead and do some testing here, I can do the same thing locally. So I'm saying .NET test configuration release. I know it will fail because of the it is expecting 10 days as 10 days for the amount of forecasted days, but only 5 is currently being returned. So it won't work. And we want the same behavior to be on our Azure pipeline. If someone made a mistake unintentionally, we don't want this to affect the whole build, to affect the whole repo. This is when we want it to fail. As you can see, it failed in here. It tells me 0% passed. I didn't do anything extra rather than add the YAML piece for testing. So same behavior is being shown here. Expected 10 days, but only 5 was provided in terms of the days. If I look further under this, you will see that now it's saying 0%. Previously it was get started, but now it's saying 0% pause. I can dive into it and look at the code and see what was paused. I can see all the information. It tells me exactly where it failed. Expected was 10 days, but only 5 was provided. It's what we are looking for. So let's go ahead and fix this, and then we can try the same thing again. So to fix this, well, I'm not going to change the test. Instead, I'm going to change the amount of days which is being provided. So I know it was 10 previously, but let's change it to, sorry, 5 previously, let's change it to 10. So I'm going to say I fixed the code. Commit this, and then I push it. If I run the same thing again that I ran previously, now it should work, hopefully. Perfect. Fine, it works without any issues. But we are looking at this exact same behavior on the pipeline. So right now it's running. Let's take a look at it, why it's running. So we want this to happen. The reason is sometimes you might want to add some PR check while you're doing your pull request. So if someone implemented a bug unintentionally, we want it to stop right there and not go ahead and don't merge the problematic branch onto your master. Then your master will be dirty, will be sort of infected. So you have to fix the bug again for all your developers to use. So while this is building, let's go ahead and you can take a look in here, right? So in here it should show you the amount of tests completed. Might take a while to run. A couple more seconds and we should be done. So running the test, 1 of 1 passed, perfect, without any issues. It's good. Now we are 100% covered in terms of our testing. We are good, 100% passed. Well, no errors in here. If we get into pass test, perfect. At this point, we are happy, we're good. Our pipeline have some testing. So we're looking into the process here once again. So we're up to this point. The pipeline now is able to test our application upon pushing the code to it. The next piece is we need and we want to go ahead and do some release. But right now, as you see, if we look into the pipeline piece, we have only one stage. One stage is boring because that's sort of one liner. We want to be able to add steps where users can go ahead and approve it, or the engineers can go ahead and approve it. So once it's built, we want to be able to say, go ahead and do some deployment on multiple environments. So let's go ahead and look into the this one. So the exact same branch right has been duplicated. The YAML is still the same thing. So what we want to do is we want to add multiple staging rather than right now we have only one stage which is doing everything. So we want to say I want one stage for build and another stage for deployment for release. You can have multiple stages for releasing to staging environment, releasing to test, release to production. You also want to say release to or maybe doing some testing on multiple VMs. So I'm going ahead and remove the pool here because I don't want a pool for my whole pipeline. I want to add staging instead. So I'm adding a stage. So I'm saying this stage in here is called build. So build application on the Ubuntu latest, pretty much the same thing. But this VM is for this stage. But let me indent this. Perfect, indented, and so this one in here, I'm adding an extra step. Let me push this and then we can look into this together. Okay, so what we are doing here is we are saying add multiple stages. You can as you can see in here, we have stage build. So if I collapse this, I have another stage which is called deploy. This one is responsible for all the building of the application, and this one we want it to be responsible for all the releases. What this one will do is it will go ahead, download the build that has been uploaded here. I mean the artifact. So in here we are uploading the artifact here, and at the end we are downloading the artifact. So we download the correct artifact, which is called drop. But we should see multiple stages. So let's look into this one, the latest one. As you can see, we have two stages. The reason we have two stages is, as I mentioned, we have build here. So once we're done building it, we want to be able to run this on another VM for the release. You can also add some checks in between. You can say really build application, release this to my staging environment. There's a check that goes on after the release to the staging environment where you want to make sure everything is good before you move on to releasing to prod. So you want to add a manual intervention to make sure that someone is validating, is doing some sanity check, some smoke testing before we go ahead and flip the switch and push it to prod. So in here, well, the exact same step we had previously, everything was deployed, was built, and it was downloaded, but it ends in here. So we don't want it to end in here. We want to do further step to it. As I mentioned, we want to be able to go ahead and release this at some point to the cloud, but in here it ends right there. But we want to take the extra step. So let me change this to another branch. So this branch, it has something separate to this. Let me go ahead and add the next snippet to this, and then I'll walk you through. This one is interesting. It has, as I mentioned previously, we need to check in our infrastructure as code to make sure it's checking. Let me push this. It might take a while to run. So while this is running, we'll walk you through this. So what this one does is, well, let me show you the file first. Let me collapse this. We have two extra files. We have two JSON files. So these are Azure ARM resources or Azure resource management files. So it defines what is needed and what has to be built. When you run this against Azure, against your subscription, so what goes on behind this is it will go ahead and create the resources for you on the fly. In here, what is being created is we have a website that will be created. We have a server form or as we call it, service plan. So this will be created, and we have a application inside that will be deployed. I have a resource group already created, and that's the template URI. It's the same thing, except that it's the raw link of the file from GitHub. So if I click on this, I open this in my browser. So that's the exact same file I have, except that the pipeline will be able to pull this and run this for me. So I'm providing both the file and the parameters so that it will works together. Let's look at this. So perfect, it runs. Once again, it built my application. Once the application was built, it run the PowerShell step, which is building my resources. So if that's my DevConf 2020 configuration resource group. So if I refresh this, I should be able to see all my resources down, which was added for me by my pipeline. If I open this website, let's take a look at the URL for the website and open this. Okay. Spinning up probably for the first time. Might take a while. Perfect. The website is up and running, but that's not our project that I showed you. So for us to be able to get the project there, we have the artifact, and now we have the website. The link is we need to be able to get the artifact deployed to our website. This is very easy. We have another step for this. So it's called the Azure Web App. So let me go ahead and push this. Push this. So what we are stating the pipeline to do is we are saying once you're done with creation of the resource at this point, go ahead, deploy this. So what is being deployed here is the devconf 2020 zip file. So this is the package that we are downloading here, which we're uploading on the build step. We are saying download this, upload this to our application or our website, which is called devconf 2020. It's a web app, and use the devconf 2020 Azure service connection for the authentication against my Azure subscription. So once this is done, the application will be deployed. So you might be asking, right? So we created the website. I mean, with the resources already, the websites, the application inside, the app service, and so on. Why are we running this again? The reason we want to run this again is this is incremental. So if I'm saying create 3 resources for me, A, B, and C, and now in the latest change I made, I'm saying now go ahead, create resource D. So what it will do, it will verify against A, B, C what is needed for me to be able to get D. So it will say D is missing at D. So this is what it will do. It will only add D for me, not destroy everything, create everything again. It will only add the extra missing piece, which is D. Let's look at the pipeline and see what's going on. A build has been completed. So let's see what was done. So exact same thing was done, right? So let's wait for it to finalize and move on to the deploy piece. This might take a while because it's authenticating against Azure and so on for the deployment piece. Let's refresh it to make sure it's running. Okay, it is running. It is currently queuing, waiting for an agent to be available. Since we are using everything from the cloud, so it might take a while. Let me show you the zip file that I'm mentioning here in my YAML. I'm mentioning a zip file. So as you can see from here, from the download piece, not sure how much you can see there, but there's the zip file. So the devconf 2020 sorry, in this one, that's the zip file we're looking for. That's the zip file we want to use to deploy to our application. So go back to the one which is currently running. So perfect. I mean, it went on this one. It realized that nothing had to be done. Everything looks good. And it skipped to the next piece, which is running the Azure Web App, deploying the Azure Web App. So that's the website I had previously. So if I hit and refresh, Might take a while to load once again because it's now contains new binaries. Perfect. Looks good. So that's the website I showed you previously, the Hello World. That's the Blazor application. The counter works great. The fetch data looks good. We don't have the 5 days now. We have the 10 days. The hit refresh, I'm not sure. You're still deploying. Okay, it might take a while. I'm not sure why this one decided that it has to stop running, but we get back to this later on. At least the website has been deployed. Everything looks good. Let's wait for it to be back up. Okay, perfect. It's back up. Azure was doing its things in the background. So we have the 10 days compared to 5 days because our parsing, our test says that it has to have 10 days for it to pass. Looks good. So let's just bring back the process. So at this point, we can say that, yeah, we're almost here. We did release the application already. Say everything looks good, everything works, but we want to go ahead and configure it as well, because sometimes only deploying the application does not end there. We want to go ahead and deploy this. So the deployment we want to do next is we want to go ahead and sorry, the configuration we want to do is we want to go ahead, configure the application to use the application inside. Even though we are mentioning to use it, but just for the sake of the demo, we just want to show how you can perform configuration on the fly for your project. For this, as you can see in here, I have my instrumentation key. I don't want this in my pipeline. I want this in a library. So I go ahead, click on library, create a variable group, call this telemetry. I'm saying allow this key to be used across all the pipelines. I'll go ahead and use this one. That's the key I want to use. And the value I want is this instrumentation key. That's the one. Save it. Perfect. Now, what we want to do is we want to modify the YAML file and say, go ahead and use the key as part of our project. This project is a little bit different. And then start up the CS file. We have application inside key that we are using. So we are saying that use the application inside key from the settings for the project, and we also have a reference here. So this way, the application is sort of connected to application insight, so we can go to application insight and see anything around it. So for this, let me go ahead and add another snippet. So the snippet is we are saying that use variables from the group which is called telemetry. That's the one we just created, and we want to go ahead and perform configuration. So the configuration in here is, so let me push this. So, okay. So what we are doing is the exact same step that we had, except we are saying as part of this, for the website, we have the app settings on the website under the configuration. What we are doing is we are adding this. So if it doesn't exist, please add it. If it exists already, please update it with the telemetry key that we have applied, that we have supplied into the. If you try to load up, probably won't, because the application does not have the SDK installed for application insight to connect to the website. And if I go into the website, what we are mainly looking for, if you click on the configuration for your website, you have a bunch of keys and connection string. In here, we have one already, which has already been added for us as part of the resource creation. But what we are doing is we're saying, that's fine, please go ahead, just add it again, because we just want to test it again. So click on pipeline and see what it's doing. So build has been completed, perfect. It's currently doing the deployment. So creation of the Azure resources. So the incremental deployment. So make sure everything looks good. Should be done in a couple of seconds. and then we'll move on to the application deployment. So in here, as you can see, the application deployment, it's currently deleting the website. So if I run this, it might tells me that the website is unavailable. Or if it is faster than me, then yeah, it was faster than me. So it deleted the application and uploaded the application again. So now it's running the configuration. So the configuration in here, if I refresh this, let me refresh the website, and let me go back to my application inside. So if I go into live metrics, let me access this. So it's connecting to my website. Let me refresh this a couple of times. You just want to see the graph. See in here, we are doing monitoring, right? So we are doing live monitoring of our application while users are using it without affecting performance. So at this point, we're up to this. We're up to this, right? So we deploy the application, we configured it, we monitor the application, and then we start again over. So if we start again over, let's get in the boards. So in here, I have the boards. My pipeline has been created. So let's assume I'm the manager of this project. I'm going to close it straight away. Then now the next step, which has been assigned to me, is I need to change the wording. So everything looks great. I just build a pipeline for all the developers on this project so they can leverage this. So now we have a new work item, which is change the wording. So for a great conference like this, we don't want hello world. We want something which is more custom, which is more significant to this demo. So in here we have hello world. So we want to change it to hello devconf 2020. This is what we want to change it to. Let me push this change wording. Let me push the change. So what we just did previously is we built the pipeline from scratch. Nothing existed, right? So we built the pipeline for the whole process. It's you did it only once for your project. What goes on behind it next is everyone's going to be leveraging this. Everyone will be able to tap into the power of automation, the power of DevOps for your project. So as a developer, I'm looking into my boards and see a work item assigned to me. I go to my Visual Studio Code, I make the change, I commit it, I push it to my repo. That's all I have to do. That's all I have to worry about. The next thing that will go on is the pipeline will pick up, will do all the necessary steps for me. So you go ahead, build the application. In case I made any change, so it will go ahead, build it, publish the artifact, test my application. Once it's done, it will go do my Azure subscription, do the resource check, create the resource, deploy the application. We can also have some UI testing if needed. On top of this, we can say, right, so deploy this to my staging environment. Once it's done, do some UI testing there. You can use Selenium or any of your preferred UI testing framework. Test it. Once you're done with all the testing, make sure everything is good. Then someone just go verify all the test result. If everything looks great, then they go ahead and say, fine, promote this to production, and then we should be good. But let's go. The website's currently down because deployment is running. Take a few seconds for this to run. Website is being deployed. A few more seconds. Package deployment initiated. Perfect. Now it will go ahead and configure it for us. Configure the app settings for the application inside. So if I reload the website, go back to home, perfect. So the website has been deployed for us with the wording. As a developer, going back to here, I say, fine, my job is done for the day. I put this back on resolve or put this back on close, meaning that's the end of the demo. So everything looks great so far. So going back to the slides, the whole flow was done. The whole flow was completed. Looks great. Now we just build a pipeline. The pipeline is ready for all the developers to use. They can go ahead and use the same thing. that's the demo which has been completed. So thank you all for watching the demo. It was really nice having you here. Please don't forget to leave feedback. And quick thing is, if you want to do the same thing again, you can just go ahead and grab this from my GitHub repo. It's devconf 2020 underscore template. On the master branch, you will have a PDF for all the steps I did. Yeah, that's gonna be it. And getting this back to you guys, team. If you have any Q&A in the, just can we'll take the questions.
Thank you, Wasim, for this presentation. It was very good explaining about the DevOps life cycle, also Azure. If we have any question if anybody has question on the live stream, please comment on the chat. I will take it to Wasim. I have a question actually. Okay, for students watching who want a career in DevOps, what path do you recommend?
The career in DevOps, I would say it's something relatively new because not all companies nowadays are really embracing the DevOps from the cloud perspective. DevOps still is, is present. Some companies are looking into it. So the next piece for them is to try to understand what goes on behind it from a development perspective, from infrastructure perspective, either cloud or on-prem, because a DevOps engineer is someone who understands how application works, because you need to be able to understand what is a test project, what is a project in itself, but also you need to understand the resources behind it. How are all the applications interconnected? So you have the application on one side, you have the resource. So you need to understand how these merge together. The best advice to be is try to be sort of a jack of all trade, because this is what really brings the developers to brings the DevOps engineer to the game.
Okay. Would you say that a DevOps is a mixture of a system admin and a developer? What are the key differences between them?
I would say not really. System admin, well, the word system admin is very vague, I would say, because system admins are not only persons who take care of releases, of deploying application. They also make sure everything is working as fine together. I would say, let's put it this way, right? So a DevOps is someone who sits between the developers and the system admin, because developers write the code. DevOps would making sure that it's sort of a glue in between. So you have the developers and the system admin. DevOps in here to make sure communication works together. So it's taking the wherever the developers left off to make sure the application gets to the point that where the system admin made sure the resources is working fine. So it makes sure that it sort of brings the gap, it bridges the gap between these two resources.
Okay, I have received a few questions. PSC is asking if he needs to run some commands after the deploy. How can he do that?
If you want to run some commands of the deploy, it all depends on how you want to do it, right? And also your resources. If you're running this in the cloud, as an example, as I had previously, I had the PowerShell step. So I'm not sure if you guys can still see my screen. Let me show you this. Let me show you this. So let me go into the YAML piece. So in here, that's my. If you're talking about Azure, you can use this. So you can just go ahead and move this or duplicate this after at the end of your app deployment. This is pure PowerShell module. Sorry, you can go ahead and say you can have a file sitting somewhere that you can say, right, so this is my PowerShell file that I can just go ahead and execute. But for this case, I'm having an inline script. You can just go ahead and execute it. The same thing can be applied here. No, this is an Azure app settings. You can go ahead and just duplicate this to have this at the bottom of your screen. If you're using in the cloud, you can use Azure PowerShell. It's pretty much the same thing as Azure Cloud Shell. If you're running this on-prem, this would differ. So rather than Azure PowerShell, you can have just a PowerShell script with all your scripts in it that you can leverage. If I want to show you the same thing from the pipeline perspective, so let's go ahead and look into this. Let me edit this. What I just showed you is sort of the YAML piece, but the same thing can be done. Let me change to the final one. Same thing can be done here. So I can just go ahead and say PowerShell as an example. So you have a bunch of PowerShell. If you're running this on Prime, so you might be using this. If you're using this in the cloud, this one's going to be the best one. So what you can do is if you click on here, you can say file path or inline. Inline, you can write your own PowerShell script here, or file path is if you have it in your repo somewhere that is accessible by the pipeline, you can just add it here, add all your arguments. That's it. You just need to add it. So after the application has been deployed, it will automatically run the script for you.
That was great. It was great to have you in this conference, Wasim. Unfortunately, we are running out of time, and I think yes, all the question has been answered. Yeah, it was great to have you here.
Thank you, thank you. And if there are more
Perfect, good.
questions that if someone might want to ask later on, you
Yes.
have my Twitter
How
handler.
can they contact you? Okay.
I mean, there's my Twitter handler that they can reach out to me on. So I'm putting it back on the screen. So that's my Twitter handler. You can reach out to me. That's my Twitter handler. You can reach out to me on Twitter. I will definitely try to get back to you as soon as I can, just to make sure everyone is up to the speed. You can also reach out to me on Twitter, Facebook. You can search me, just ping me or anything. I would be more than happy to help you out, guys. Thank you.
Okay, great. That's good. Thank
So, hello, you're back,
Top
and
of the
we now
morning to you all.
Javin on stream. Yes,
We now
yes.
have still in still in the DevOps field, I would say, Neil. We now have Javin Boiro, our next speaker, who is going to talk about Azure DevOps for your mobile release. How are you, Javin?
Guys, just had my morning coffee, so feeling great. How about you guys?
Oh, that's good. That would be very helpful for the presentation.
Yeah.
Yeah, great. So tell us a bit about yourself. Where do you work? Are you working today?
That's a very good question because I have a slide only for this. I'm just gonna switch to that slide. So yeah, I've been a bit lazy here, just like most developers. So I work. I'm software engineer at MCB. So lately, I've been working on a fintech app. It's a very famous app, which you guys will also know about. Beginning of next year. I started in the digital factory using Angular. So I was a full stack web developer. Then I switched to mobile development. So this is why I'm very excited. So this is why I'm very excited. What I've been learning about, how we can use Azure DevOps to automate our mobile release. One thing about this fact, just now I had my coffee. Just now every day I need to have a coffee. So every day in the morning to feel, in the morning to feel good. So that's why this tagline turns coffee into good to make the digital transformation happening.
That's a good tagline. That's a good tagline. MCB is planning to release MCB is planning to soon.
Yeah, sure. So
right?
just before my presentation, I think Vincent, our CEO, talking about it in watch his YouTube streaming later on. So beginning of next year, we'll be releasing the Juice 4.0. So you have more details on his presentation. I invite you all to watch his presentation.
Okay, we will put a note at the end of this presentation. Anyways, Kevin, you can start your presentation about DevOps at MCB.
Cool. Thanks a lot. Thanks a lot, guys. So I just thought, thank you. I had my cup of coffee. So why are we doing this presentation? Why using Azure DevOps for your mobile release? The thing is that releasing any mobile app manually is cumbersome, right? So I'm just gonna take Android app for example. So releasing an Android app manually, like I said, you have to build your app. You have to build your app bundle. You have to find your key to sign in and step through Google console to get it out of the door. And then certainly, like for small apps, you can do this easily, right? From time to time, you can do this, right? But when it comes to like big application, it's quite difficult to manage, right? So in this short walkthrough, I'll lay out the general steps on how you can use Azure DevOps, and I'll show you what's a pipeline, so that in a single commit on your code base, you will be able to have, which it will trigger a new App Store release. So in this presentation, we are going to use App Center. We're not going to release directly to the Google Play or the Apple Store. It's the same step for the Apple Store, so same step for Google Play Store. And you can do this for any type of, you can do this for Flutter, for Android, for Apple, iOS. And yeah, that's why we have this logo. I love this logo, like this cute guys, cute Android logo. Yeah, cool. So let's get started. I think Tej has already talked a bit about me during this, and then so I've been telling you why we cannot do this manually, because developing it manually, like mostly for a big app, it is repetitive. If you have to do the release manually, it's time consuming, and as you all know, time is money, and most probably you will make some errors, right? Human make errors, whereas robot, we are not so sure yet. So normally what you do when you release your app, so you build your application in release mode, you sign it using the key store file, and then you save the signed APK, then upload it to the store. Of course, you can do all this manually, but again, this is why we don't want to do this. These three reasons. So this is where we introduce Azure DevOps. The idea is to automate this process using a really good tool, Azure DevOps, the process is called continuous integration. The interest in using the Azure DevOps is that it can be accessible from anywhere. One. Second, you will not be in charge. You will not be charged. You will not be in charge of the server maintenance. You don't have to worry about this. Third, it is not very expensive compared to the gain that it brings on your projects. And third, we will create something called a pipeline, which I told you about earlier, that will allow you to generate your APK with just one click. Good. So how cool is that? Let's jump into the demo. So let me just switch my browser. So let's go. Let me know when you can see my browser. That will be really cool. I'm just sharing my browser. Can you guys see?
Yes, your browser is on screen.
Great. Thanks, Neil. Really helpful. Okay. So I'm just gonna show you what's a pipeline. So here you've seen that I've been playing with a few pipelines. Yeah, last time was yesterday. Yeah, good. Let's see how we can do this. First of all, before I jump into this, remember that this is an I'm sorry, I'm bad at this word, but it is an introduction to the Azure DevOps and the pipelines. So if you have any more questions later on, this is not an expert session. This is just for a beginner level so that you can get your hands on and understand how things work. And also after this session, I will send a few links so that you guys can try it on your own. I think the post will pass on the links to you. So let me show you how I did it. So I want to first of all show you what's already here. So I have two pipelines here. Good. I have one is for the PR and one is the build pipeline, the actual pipeline. So if we open the pipeline, here we edit it. You will see here, that's a lot of technical stuff, right? But if you are an Android developer, iOS, or any kind of developer for mobile app, you will understand that what we are just basically doing for an Android app, we are just running the Gradle task, clean, assemble, debug. We don't have to do it manually on our Android Studio. And then we are just copying the APK to a target folder. Once this is done, we are just publishing the artifact. That's one of the pipeline. And then once this is done, we run the second pipeline. So I'm going. Here we go. Sorry. Just happy to see the green tick. When you see the green tick here, you should smile because that means good news. Okay. So you see here some red cross. Now let me edit this pipeline. Here. So I'm going to show you how to create this. I just want to show you here what is already in my pipeline. So again, I'm triggering on the master branch, and then I'm using, this is an agent. My agent is the macOS latest agent, which will do the dirty work for me. I don't have to do it manually. Thank you, Azure DevOps and agents. And then this is my task. This is very interesting. I will show you that I can use variable in my pipeline. So you will see here variables. Good. And then you can also, so each time you release a new app, you can automatically increment the version, the build number. So I have commented this one up because I want to show it later. Also very good is that you can automate your generation of release notes, so you don't have to type it manually each time. So we are already doing all those. Here we are finally distributing to App Center, which we'll use. And you will see the App Center where we're distributing our app. And there is our Android. Good. So if you want to create a pipeline, so you just have to create. It's as easy as this. You click on New Pipeline. So here, what's happening is that let's say that you're a very beginner and you want to automate the release of your app. You don't know much about it, and you follow my session, of course. It's very easy unless you follow my session. Yeah, it's very easy, but you can choose. It's very explicit. So where is your code? You can choose. So I will just select it is an Azure repository, and here's my app. My app is an intro app. So I'm just gonna click on it, and it says configure your pipeline. Okay, you can choose whether it's a Gradle, Android. Yeah, I know at the back Android use Gradle, but still give you the option. You can either use a starter pipeline with minimum configuration, and or also what's very interesting if another team or another someone else who has a pipeline which you think you can reuse, you can even use that, right? So you can see here existing. So you have a lot of more options. I'm not going to go through that. You can see here a lot of options. So let's say that you want to do for Android. Just click on Android. As easy as that, right? So you will see here that you have the YAML file, so the configuration file, so that you can help you build your Android. So I'm not gonna do it again, so because we already have this. I'm just gonna move this here. Good. We already have our YAML file. Cool. So I'm just gonna cancel this one. So back to the pipelines. Good. Now let's go into the details for build. Open this one and then edit it. Cool. So as I was telling you guys earlier, so we want to trigger like a build. So whenever we build our code, we want to trigger this pipeline. So how it works is that it's like an introduction demo app. I got this from CodePath, which is a good site which you can refer for any Android stuff. I think there are other stuff also. So you will see here, this is my app which I want to deploy. I don't want to do it manually. So let's see how we can do that. Here, once let's say that I have my code and changes. Let's say that I just want to edit this file. I just want to put live demo. The moment I do a change, let's see what happens. So I commit. So guys, never commit on master. This is only for a demo. Cool. Let me just commit and see what happens. Cool. You see here, I have committed my code. So this happens usually when you have another developer or you yourself, you're working on your project and you made some change, right? You just want to make some change, but you don't want to go through the step of rebuilding your app again, signing it again, deploying it again. This is very tiring, right? So each time you make a change and you have to do this, damn, this is tiring. So once I've done a commit here, I can even create a pull request and from master to master. So I think you won't need it because it is the same, no changes. Good. Now remember, I just made a commit. Now let's see what happened. As soon as I made a commit, you see that the pipeline start running, right? The first one, I have 4 right now, but because this one I can cancel, but the top 2 are the same. I just cancel it. Good. Yeah. So as soon as I made a commit on the master branch, as you've seen, what happens is that the 2 pipeline start, right? They start running. So let's see what's happening here. Let me go inside. You can see here that there's a job that has been queued, and if you open, you will see that it is acquiring an agent from a cloud, trying to run the job. Cool. Now the job has started. Let's see what's happening. So the PR pipeline. So you're just gonna build it in debug mode. If you remember here, let me go here. If you remember what this pipeline specifically is doing, is that we are just acquiring the agent running on the master and then just running this stores, clean, assemble, debug. Good. And what you will do next, it should be copying this output file, which is an APK, to our artifact staging directory. And once this is done, it should publish the artifact. So let's see whether it is doing this or not. So as you see here, it has started a Gradle daemon. Apparently, the subsequent builds will be faster, but we don't have enough time for this. Let's see what's happening. In the meantime, what we do is that I will show you the build pipeline and what are the different tools that you have, so that you don't need to worry about how you will connect the app, distribute, how you will make this. For example, so those you will see here, even for the assemble release, I have put a variable here and variable. So what it does, basically, it just do clean assemble release. Cool. You can set as many variables as you want. The advantage of this is that you don't have to modify your pipeline here each and every time and save it. You can just do a quick change here, then run your pipeline. Also, the thing is that if you have some sensitive data or some kind of password you want to save, and you don't know how to put it in the, like you don't want it to be in plain text in your pipeline, you just add a new variable, and let's say that this is variable is a password, and I just want to put the value a password. The thing is that you can keep this value secret. So once you do this, it is as easy as this. But anyone looking at your pipeline won't know what's the password, and any other team using anyone else using your code, your pipeline won't know what's the value of a password. As easy as this. So you just have to add it. I'm not going to do this here, but this is what I did over environment. So here it's a clean assemble release here. Also for AppSlug, AppSlug is the it's like your username and then slash the app name. What is this? It is used to connect the App Center to your Azure DevOps so that it can recognize it. So here you will see that I've put it as a variable. Tomorrow I decide to change to do another app. I just need to update it here. Say intro something like intro 2. I just need to update it here. And I just need to click on OK. It will run the pipeline again. I don't have to modify the pipeline variables. Now let's see what happened. Good news. We see the green tick. When you see the green tick, you know that your build has been succeeded, and very good news. Okay, another thing. Let's see what your pipeline has run. What happened to the build? Oh wow! It has automatically started the next one, the build one, the actual build one. So that's pretty awesome, right? You don't have to worry. Just imagine that you have a commit. You made a change to your app. Let's say that you just started in the Android world, and then you made let's take some good example. Let's say that you took an app like a financial app, and that instead of rupees you have written like euro, and that's a big change considering like 100 euro and 100 rupees are huge difference, right? So you make this commit and you made a mistake, right? So what will happen? You can easily change it right away, and with a single commit, you change it, the two pipeline will be run. So once the PO pipeline has been run, the build pipeline will run. As you can see here, while I'm talking to you, the build pipeline has been run. It took me only 2 minutes, 3 seconds, right? So how awesome is that? So let's see what happened in that. As you can see here, I updated the README file, if you remember earlier. So here it is. Updated README file. It gives you all the information that you need. It was run on master. This is the commit ID. The job was a success. You get the details. Wow, awesome job. I think yeah, and then you will see here one published. It means that it has generated an APK, and this has been published. It even give you a path where you, as a developer, you can download it and play with it around, right? Just a short note, this application is not signed. This is just an example for the demo, so I will leave it as this only. What's also very interesting is that you can use the same thing, the pipeline, to sign your application automatically. You just need to know your key store and the other details, and then on your pipeline, you don't have to sign your app each and every time again. The pipeline takes care of this for you automatically, thanks to Azure DevOps pipelines. Right. So as a developer, I can download the app from here and then use it. But as an end user, for someone, or as someone like not in the tech environment, like say that I want to tell my product owner or my business analyst, if you any team or anyone business people to test my app, how will they do this? Because they are not techie people, right? They are not tech. The thing is that this is where once it has been published, with what's saying published, let's see what happened. Once the pipeline has been run, let's see what happened. Now we are now here at App Center. App Center is just like just any of the application center where the app will be published and someone can log in and download. Why we have put I'm using App Center? Because I don't want to, use the platform like Google Play Store or Apple App Store to show you guys here. Even though from here you can distribute it to App Store, or you can even distribute it to to App Center, to App Store, to Google Play Store. So let's see what happened here. An overview. Oh, great. So today's the 9th of September. I just want to see all of our releases. That's pretty nice. So if you see here, just now, at like 4 minutes ago, our app has been released. And just now, just imagine what we did for this to happen. We just did one change, one commit, and all of this step has been automated. Good. So I'm just gonna try and see what's up there. Yeah. Oh, nice. Even my release notes is included in this. So let's say that your users want to know what's up in the new app. You even have a release notes. So I mean, what can you ask for more? Good. So what I'm going to do now, I'm just gonna, if I want to test it, I just download the app. I click on download, and then here it gets downloaded. And I can just test it on my app. So since this is an unsigned app, I'm just gonna use the one that has been released in debug mode. Let me just share my whole desktop for you guys. You can see it. Share. Can one of the hosts let me know if you can see my emulator on the screen? My Android emulator.
Yep, it's on screen
yes,
right now.
we can.
Good. Thanks, guys. I think you guys are awesome hosts. Okay, so I'm just gonna put the app debug one because this has been released as you saw, but I'm still gonna install the app debug one because this one is unsigned. As I told you earlier, I'm not going to sign the application. So let me install it and see what happened. This one also was generated from a pipeline, from the PR pipeline. Let's see. Oh, did I just install it without showing you guys? Let me uninstall it again. Good. Install it. Now, installing. Wow, that was false. And I open. Cool. Guys. So one commit on master, and then you have your app up and running on your emulator without any for you to build without you having to sign application, without you having to do almost anything. So again, I would like to let you know that you can do this by exploring the Azure DevOps, the App Center, and the different. So what's also good is that you have a lot of options, a lot of options. We also have this thing called the Visual Studio Marketplace. So I would like to let you know Visual Studio Marketplace. Here, the marketplace. So it has the extension for Visual Studio. This was one, I think, Azure Marketplace. Yeah, Azure Marketplace. Good. So the thing is that you will see in my pipeline, you will find different tasks. So what you see here, for example, this one, like I want to automatically increment the different build version. Done earlier is that each time I release my app, I would manually change it, right? Android developers would know that I have to change it like from version 1 to version 2 to 3 each time I have a release. But we don't want to do this. As developers, we want it to be free. We just want to code. I think you all guys agree. We hate meetings. We hate manual things. We just want to automate everything. So at least I want this. So one of these things is that how we can be done in your pipeline. So we add something called a task. A task, even if it is not available here, you will see how we have a lot of tasks. So let's say if I am looking for a task manifest, it's not available. Even though it's not available here, you can get it from the Azure Marketplace or some. It's not this one. It's like from this market. I will also send you guys the link so that you can find it by yourself. So let's make a quick Google search to see this one. This marketplace. Yeah. what VSTORs is about, right? If you want to add VSTORs, I want to automate how do you say this one? The version of my app. I just Google it, and here, I was right. It was the Visual Studio Marketplace on here. Here it is. So it's an mobile app tools. So you see, what's really cool is that even though the tools is not available on Azure here, you can install it from the marketplace, and then it tells you here what it does. You see here, change app version tools to update the Android manifest file. So these tools help you to automate the bumping version numbers and changing package date at build times. So you're not limited to what is available, and so this is one of the things that I've been using. So each time we release a new app on App Center here. So right now, if you see, it is 2.0. It is only 2.0. It stays like this. And you don't want this, right? You don't want to release an app where it just says 2.0. You want it to like 2.0.1 or 2.1, 2.2, 2.3, right? And using these stores here, you can do this. Right now, I've commented it because for the demo, I wanted to keep it very basic so that you can take baby step and release your own app at once. What's also very good is that one of the other tools that's available, which I found very, is that you can generate your release notes automatically. So let's see here. This is one of the tools which I found very helpful to use with Azure on Azure. So I just need to click on get it free, as simple as this. Then it will add it to my Azure platform here, Azure Developer Platform, and then I can use it. As you can see here, you just have to specify the you just have to specify what you want, like what will the output files be, and what you want in the release notes. I have also helped into automating this also, like the build number, what it is, what are the different pull requests, what are the changes in this release. So you don't have to do anything, right? I mean, wow, I'm just mind blown when I did this for the first time. So I looked into this like years back, but I started, implementing this like in November 2019. So like around 8 months ago, 10 months maybe, 10 months ago. And what's also cool is that if you now, let's say that I've deployed, I've released the app into App Center, but you have a Google account or you have an app and you just want to push it directly from your Azure pipeline to the Play Store. So how would you do that? So as I told you earlier, let's see. So the tools is not available here, but you can add the tools. You can add the tools Google Play Store for this. Let's do something else. Let's say that okay, I have my Android app. I was telling you earlier. I want to sign, right? I don't want to do this manually. So how do I do this? So just go here. I just say that. Okay, sorry about this one. Okay, good. Then I just say, hey, I want to sign my Android app automatically. So these are one of the tools. So let's try it out. Oh, wow. So here's the APK file. You just have to specify where the root of the app is. Just say, hey, I want to sign this APK. Let me put the key store file. You need to do this only once. You don't have to do it multiple times. Remember, once you do this, you don't have to sign it manually ever. Good. So this is the key store file. You put your key store password and all the other information. If you want to zip align, you also have the different options to zip align here and and you just click on add. As simple as that, it will generate the code for you to sign in your Android application, and then you're done. So how awesome is that you can sign your application, build your application, sign your application, connect it with App Center, release it to the Play Store, to iOS Store, all of this with only one commit on your repo. I mean, this is pretty amazing to me when I first discovered this, and I wanted to share this with all of you. Also, the thing is that once you have done all of this, you have used Azure DevOps, you have not only pipeline, you also have different options that you can explore. So we can so we see have a small thing called release. So this one is very specific. It says that you can automate your release process in few steps with a new pipeline. So this one is when you want to schedule the release, like say that I want to have a release every day at 5 a.m., at 10 a.m., so that my team can have actually we did that. So that my team, or even my tester, so my testers like to sometimes wake up early in the morning, 6 a.m. to test the app for some reason. So what I did first of all, the first thought that came to our mind was like, no web developers are going to release an app for you at 5 a.m. or 5:30 so that you can test it at 6 a.m. So the little trick was that you use the release pipeline, and every day an automated release at 5 a.m. would go out, and the testers would then wake up at 6 and then test the pipeline, test the new app. So in their mind, they thought that the developers were waking up early, but it was just a pipeline. Good. So as you can see here, it's as easy as just clicking on new pipeline, and you can select. You have a lot of options. You can deploy Java up to Azure App Service, blah blah blah, or you can even just start with an empty job. So let's say that I want to start with an empty job. Cool. I'm now in stage owner. Nice. I don't know what it means, but nice. Okay. So just close it and says here what you want it to do. You can even add the artifacts. So what's even cool is that the artifacts come from the Azure repos, so you can already select it. You don't have to do anything else. You're just clicking a few clicks. So what's the default branch? I want it for master. I want the latest from a default branch, and just click on add. And here you go. Your artifacts are set. And this is what I was telling you about the schedule. So here, I just enable the release. So every day, oh cool, at 3 a.m. every day at 3 a.m. it's going to release a new app for us. So yeah, I mean that's pretty amazing, right? So every day you're sleeping, and at 3 a.m. your app is being released, and you're in your sleep. When you wake up, and someone says, "Hey, I got the new app." I said, "Yeah, I woke up early for you, so only so that you can get this app." Good. And yeah, so here, and then you can add what you want on the agent. So what you want the agent to do, you want the agent to sign your application, as I said earlier. You just have to click on add here. As easy as this, you get visitors. Then you can distribute it to App Center. I just want this. I click on add. I want App Center to test the app. Again, add. As is. Then here I go on sign and aligning application. I just configure it. I just put my information here, what I want. I want this connection. I want XYZ absolute. I want this, the build version. And then if I want my release notes manually, or I want to select it from a file, as easy as this, and we are done. We have a pipeline here, which can sign and allow your application to APK. You can deploy to App Center, and you can also test it. Good. So I think that we don't have much time left. We have some 10 minutes left. So I'm just gonna talk to you a bit about the App Center also. So you will have a little configuration to do here. I'll show you the configuration for the Azure pipelines. So for App Center, just go here. So on here. So let's say that I want to add a new application. So this one is for intro app I wanted. You can have as many apps as you want on App Center also. So if you click here, I just want this. So I'm just gonna put some desktop, and here you choose your release type, whether it's alpha, beta, whatever you want. So it has no such like consequence if you choose any other. So I'm just select alpha. Then in terms of OS, I'm just gonna use Android, and as developers know, it's either Java or Kotlin. So the performance is this. I love Java and Kotlin. So add it. Yeah, we have a new app, and all you have to do is then select where the repo is for this app. So for instance, it stays on Azure DevOps. So you just click Azure DevOps. Yeah, from time to time, I think App Center build is experience some issues when they do some server maintenance. So that's totally okay. So I'm just gonna say personal training, select the intro. And we are done. So we have our master branch connected to this App Center. What was the last commit? If you remember in this presentation only, we updated the README file here. And then here you can configure your build. You can even build here. So you just have to choose the variant, what you want. You can even specify environment variables. You can sign your builds from here also. You can even test on a real device. That's free. So yeah, you can save and build. Yeah, and here I'll just let it build. And then what's cool is that app has been released. Once your app has been blah blah blah, you don't need your non-tech people to come in here and sign in on App Center to understand what's happening. Yeah, technically they have to sign in on App Center, but what's very nice is that you can distribute your app to groups of people. So here, let's say that here I have, let me see. Okay, I have a group of testers. So for right now, I'm the only tester. Sadly, I'm the only tester. I think I asked my team to test this app. So what you can do is that you can just manage and just add a few people here. So let's say that I want to collaborate with Shervin. At mcv.io. I just put in his email, enter, and then I choose his role. He's a developer. He's a developer or manager, blah, blah, blah. So I just put him as a developer. And then once the app has been released, let's say that Shervin is a non-tech guy. But once the app has been released, every non-tech guy will receive an email with a link to download the app and to understand what's it. What's also cool is that the release notes are also in the app. So I'm just going to show you how it is in terms of email. So even the email is included, like, I mean, let's see here, Azure DevOps. So this one is our pipeline, that the pipeline has been run, okay? So this one is good, but what I wanted to show you is for the App Center. It's here. See, I have received mail from App Center saying that, hey, a new version of my app is here. So just imagine that your people, your non-tech people, the person for whom you're developing, even the QA, and you don't have to every time, you know, hey, a new release is there. So we'll automatically receive an email when you click on it. Hey, cool. So a nice mail saying that a new version of Intro for Android is available. What's the app name for Android? And you can just click on install here. And then the guy just need to install it. And also what's good is that you've seen earlier that I've put my release notes as my first release. And in the mail itself, we will already see what's new in the app. So if, let's say that I change the money, like the money currency from euro to MUR, like a bug fix. So we will already see, hey, in this release, we have fixed this kind of issue. So you don't have to manually let them know, hey, I changed that. So in the email, they already get it. So yeah, that's here. And then, yeah, so I've played around with Azure DevOps. Why now? I'm also very beginner at this. I'm not expert yet. Yet is the keyword. And I've also played a bit with a mobile app and everything. So I wanted to share with you guys like what are the cool things you can do with a single commit using Azure DevOps to release your mobile app. I've also noticed that lately people have been using this to for Flutter. So you can build your Flutter app, then use the same process, the same steps to release your app. So that's pretty much it. Thank you. I'm just gonna share this one. If you want to talk to me about this, if you want any links that you need, please do let me know. I'm available both on Twitter and LinkedIn, or we can even have a mail also. It's the MSCC website. So feel free to come and have a chat. And even if I can help you to release your Android app, so that would be great. And I encourage every one of you to play around. It is free to play around. So what I just showed you was totally free. So the Azure account I used was totally free. I think I signed up on Microsoft Azure and I got a free account. The App Center account is again free. I just signed up. Yeah, App Center and Azure DevOps and your pipeline. So if any one of you is getting into the Android world or any Flutter world or iOS, already have those, but you've been building, signing, and releasing your app manually, and you want to automate this process, I would request all of you to please give this a try, the Azure DevOps, and try to release your app through the pipeline. So each time you make only one commit, and you don't have to worry about this, like you have to build it manually and anything like this. Only one commit is enough for you to have your new release, and people can enjoy your app. Thanks a lot, everyone.
Thanks a lot, Jevin, for the presentation. It's just remarkable how Azure DevOps streamlined the mobile development process. I'm not a mobile developer, but I find it to be so quick.
Cool. So maybe you can give a try to mobile development now.
Maybe I can. Maybe I can. So let's see if we have any questions. Yes, Joshua is asking, what is required for a newbie to get into DevOps?
So what you've just seen is that it does not ask you much of technical competencies, right? You need to have you need to have some technical background, but not like you don't need to be an expert. As I just showed you, I would like to show you again. As I just showed you. Where is it? Yeah. So I'm just gonna put it here, and then I'm just gonna move this. Okay, can you see the screen?
Yep, your screen is on right now.
You can see it, right?
Yes.
Okay, good. So for Joshua, that's a good question, Joshua, because I had this question too. So many people ask me this question like if I'm not like expert in DevOps, can I use this this pipeline? So yeah, totally you can, because it's as easy as just clicking a few buttons, and then you have your app. As I showed you earlier, you can even use the classic editor. So Microsoft, what they did is that they kept the classic editor. If you don't want to go into too much technical details, like creating your YAML file, you just use the classical editor. What it does, it basically gives you the options, like in plain English, you can configure. It's as easy as select a source where your source code is. You see here, I use my team project, my repository, and what branch I want. I click on continue. Then just tell you, just say, hey, what do you want to do? I want to apply this one. I just want to build, test, sign, and align my Android APK. Just click on apply, and it does everything for you. It does the build, it shows you the build, it does the signing and the aligning, it copies the file for you, it drops it. It even gives you an option to test it with Android with App Center and also deploy. You can as well as enable restores or disable it. So you don't need anything like any technical specific competencies to do this. As is as those.
Okay, good. Next question we have from
from Oklu Pravesh. He's saying that when you say publish application, do you mean on live instances?
No, so what I mean like I'm publishing my app is that I'm pushing it to the App Store, Google Play Store, or how do you go for the iOS one, the iOS App Store, I guess, iOS App Store, or even the App Center. This is what I mean by I can publish my app there and just pushing it to the Play Store. It means that I already have an account on Google Play Store and I want to push a new release there, so I can do it via my pipeline.
Okay. Thanos has 2 questions. He wants to see your build Gradle file, and he's asking if you tried the security scan packages to find security issues.
Cool. Thanks a lot. Like Thanos has already always those great questions I've been expecting. So yes, you can see the Gradle file. We can even have a session one-to-one so that you can go through it. You can go through it. So I'm just gonna show you here. Where is my group? Okay. If you want to see my Gradle, I'm going to do. Okay. So again, I would like to remind you guys that this is a sample app. So even though so yeah, if you can see my screen. Oh no, I'm using the wrong project. I'm sorry. Just gonna push to the right project. Yeah, it is. Yeah. So this is basically a sample app. So I would like to let the audience know, and Thanos also, that this is a sample app. So this is how the Gradle file is right now for the app. And if he wants, we can have he has my details. He can contact me via LinkedIn, Twitter, or even WhatsApp call, and we can go through this together. And yeah, for the second part of this question, can you repeat again? In terms of security, I think he has a question.
Yes, he was trying. He's saying if you tried the security scan package to find security issues.
No, but that's a very good suggestion. I've not yet tried this, but thanks a lot for this one. I know he talked to me about this once, if I remember well. So I've not yet tried this, but I will make sure to give it a try. Thanks a lot, Thanos.
Good question from Thanos. So last question we are taking from Hernom. He wants to know if you can plug in some analytics tool on the same platform.
Yeah, totally. So you have let's say this. I've not yet tried it, but I know some of my colleagues have tried to plug in some analytics tool on this, whether on both on App Center and on the Azure here, so that you can use to get the data that you want. So totally, I don't have anything. I've not tried this personally. I know my close colleagues have tried this, and it got it working and got some pretty useful information that you can leverage upon. I will try to connect with my colleague and get some more information, then connect with her now. If you first can give me his information, then I will let him know more about this one.
Okay, great. I think time is up. Thank you, Javin, for this awesome presentation. You make me want to try mobile development as well.
Cool. I'm happy at least I got someone on board. So thanks guys for being awesome hosts.
Thank you. Thank you for presenting.
Cool. I really like that MSC gave us the opportunity to show the world what we are trying also. So I would encourage everyone to give it a try. And next time, we'd like to have more speakers on board also.
Okay. It was our pleasure. Her name is saying he's Kaushik, by the way. You might know.
Oh, cool. That's a buddy of mine then. I will connect with him later on. Cheers.
Okay, good. Cheers, mate. Hey, bye-bye. And don't forget to log out, Jevin, for the next speaker.
Sure. Have a good day, guys. Cheers. Bye.
Ciao.
3, 2, 1. Hi everyone. So now, and Chitesh, tell me a little bit about our next speaker.
Hello everyone. Please welcome our next speaker. He's Joseph. He's the Director of Technology at Quicken Loans. Welcome, Joseph. How are you doing today?
I am wonderful. A little tired, but wonderful. It's 1 in the morning here in the United States, where I'm coming from.
Oh wow.
Ah, yes, it's very early in the morning. Have you had a chance to get a coffee yet?
I got a gigantic cup of tea right here in front of me. So,
Good,
yes.
good. Yes, it's 8 hours, I think. Here in Mauritius, it's noon.
Yeah.
Noon right now.
Yep, we're at 11-hour time difference right now. From where I am.
Yeah. All right. So we'll leave you to your presentation. Maybe you can start by introducing yourself and what you do. Good?
Sure.
Good luck.
Thank you. Hi, my name is Joe Guadagno. I am what we call Director of Technology at Quicken Loans, America's largest mortgage broker. I am here to talk to you about how you can help your application scale with Microsoft Azure. A little bit about me. You can follow me on Twitter, Facebook, LinkedIn, my webpage where I stream usually 3 times a week. I'll probably stream after this episode at jjg.me/stream. So we're here to talk about Azure. I'll pull up the slides at the end for the contact information if you need. We're going to walk through a couple of different pieces of Azure. We're going to start off with a basic, I don't want to call it Hello World app because there's a little bit more than that. It's a contact application that has a API to it, a front end using MVC, as well as a database component. So we're going to start off by publishing this web app and the API to Windows Azure. We're then going to go and update to it to be hosted on Azure. Then we are going to create what's called the blob storage container. That will allow us to hold our images within the application. It's basically a contact application. You can add first name, last name, date of birth, that kind of stuff. And we store our images right now locally, but we'll end up storing them in Azure to allow us the ability to kind of grow without running out of disk space in theory. And then we probably won't have any time, but if we do, we'll dive into hosting those images on a content delivery network and then maybe look at application insights. So that's about all I have for the slides right now. So I'm going to stop that. We'll minimize that. We'll go take a look at the code. So you notice first thing that's slightly different is I am using JetBrains Writer. Let's go and change the screen resolution a little bit so that it's not super tiny on your screens. Let's go here and fonts and change the size. Normally I would have done this beforehand, but I totally forgot. So let's do that. Good news is we're not going to spend a lot of time in Writer. This is just to kind of give you a walkthrough of the app. So let's start off with running the API and the web app. And then it started off on a different screen. Let me pull that in. So here we have the web API. You call the contacts endpoint and it returns you a JSON list of all your contacts. So let's go and change that a little bit and go to the web UI just to show you what that looks like. And then we're going to go walking through the promotion. So here we have a simple ASP MVC app. There's a home page, which you see here. Privacy links. If we click contact, you have the ability to see contacts. I can click on any contact to see them. See there's a nice little image of me. I can click edit and see more details of me in there. And we're gonna have the ability to upload images. Ignore the URL for now. That's just me hosting it locally. So that's it for the app for now. So first thing we're gonna do is go over to Azure and we're gonna start creating a couple of resources. Typically, before I create resources, I prefer to create a resource group with it. So I'm going to go to resource group, hit create. And what resource groups allows you to do is to have a kind of grouping of all your resources together. I know I use the same words in the description, but just think of it as this is one big gigantic container that I can throw everything in. And this allows for easier maintenance later on, especially if you're hosting a couple of different items in here, which we're going to do. It allows you to see them all together. If I was to show you my current Azure subscription, you'd probably see that there are, I don't know, like 50, 60 some odd different things that are sitting there. So without the grouping of them, it makes it a little challenging. So you can assign resource groups to regions. You want the regions to be close to wherever you are. In this case, since the closest region to me is West US 2, that's where I'm putting it. I click review and create. Validation passes. You'll see that for each individual resource we create. Once it's done, I'm going to click go to resource group, and then we're going to go and add a couple of resources. First set of resources we're going to add is what's called an app service plan. So I'm going to click new and then search for app service and search for app service plan and then create. What app service plan is essentially a series of web servers for your, in this case, resource groups. So we're going to host our different web apps on web servers using the app service plan here. And I'm going to give it a unique name. In this case, I am going to, everything I'm prefixing here is with the LAA, which just stands for Lap Around Azure. I kind of do that to organize a lot of my resources together, even though they're inside of groups. In case we don't see them in groups, I know which service is which. You notice there's a little check mark here, meaning that I met the requirements for it being a unique name. I'm going to choose the operating system. You can choose Windows or Linux. Since I'm running .NET Core and some other things, it's just easier for me to choose Windows, but you can choose whatever you want. And then I'm going to choose US West 2 because that's where everything is going to be together. I kind of wish it really defaulted to that based on the resource group. And then the pricing tier. This is kind of the type of servers you want. I'm going to click change size just so we can see. Now, typically when I'm doing these demos, I would pick a D1 because this is just for local development for us. And it gives you a rough cost of it. However, these are shared infrastructures, as it says. And when I'm doing a demo or something like this, you could get kind of limited or rate limited with things. So for the demo, I'm just going to choose a standard image, which the cheapest they have is $73. And it comes with a bunch of features. Again, these are prices in US dollars. We're not going to cover most of these features in this. We're going to kind of do a quick walkthrough. Click apply, and then first thing we do is review and create. Kind of gives us an overview of everything we're doing. Click on create. And then the deployment is in process. This is essentially VMs for us somewhere in the US West 2 data center. Once this is done, we'll get the deployment is complete, go to resource, and then we're going to see a bunch of different options here. We're going to come back to some of these later on. But you see right now what our CPU is, memory percentage, data in, data out is. We haven't done anything yet, so this is going to be pretty small. Click on apps, and there's no apps hosted in here yet, so there's not really much for us to see. So let's go back to overview and click on home, and then we're going to create a new resource. Now we're going to create our web app. So web apps, think of these as IaaS applications that allow you to store things like Node.js apps, Java, Ruby, .NET Core, ASP.NET. We're going to create 2 of them, one for our API and then one for our MVC app. So I'm going to click create. Let's pick that resource group. Let's give it a name. As you can tell, I've run through this demo once or twice, so Microsoft Edge is filling in the blanks for me. You have the ability to choose code or Docker container. Right now, I'm going to choose code. I don't want to introduce Docker to this. I'm going to choose the runtime of ASP.NET Core 3.1, but you can choose whatever is applicable for your application. And then here it says, not finding your app service plan, try a different region. I don't know why it defaults to Central US when the region for the resource group is in West US 2. But once I choose West US 2, you'll notice here it found at least one resource. If I scroll through, it's going to show the other resources and the size that it's doing. If you wanted to, you could have created a new one right here, which would have taken us through the same steps, but I wanted to show each step individually. Let's click create. It's going to create that resource. And we're going to go to I'm going to open up a new image because we're going to swap back and forth between these two. And we can probably close this off. I'm going to create another resource now. And this is going to be a web app. Now you notice right now we're creating 2 different web applications for it, and they're hosted on this one server. So it makes it, we're not increasing costs by running more than one of them at a time. And this one we are going to call this one law-web app. And do the same thing, code, .NET 3.1, pick West US 2, and then pick the server for it, click review and create. Click review and create. Now that's creating. Let's make sure the other one is done. The other one is done. So we're just going to click go to resource for now. And then we're going to open up a third one. And the only reason why we're opening up these is just because it makes it a little bit easier to swap back and forth, because we're going to be coming back and forth to the API, the web app, and this new page that's still deploying. So now we're going to create our SQL Server instance. For this one, we're going to create an Azure SQL resource. Now this creation looks a little bit differently because there are 3 different types that you can choose from depending on your flavor. The differences are this one here, SQL databases. This is a managed connection. This allows you to, or this has Microsoft manage everything for you and essentially just creates the database for you and allows you to interact with it. Managed instances are very similar, but it's a full-fledged install of SQL. This you're using SQL as a service. This you're using their hosted version. And this is a virtual machine, meaning you have the full control over the operating system, patches, and everything. For our case, we're going to just create a simple single database. Let's choose our region. Let's give it a database name. We're going to call it contacts. And then a new server. We don't have a server for this, so I'm going to create a new server and then give it a name. So here we're going to do, let's see what I call law-SQL server. Give it a username, and then I'm going to copy a password over from another screen. It really doesn't matter because I'm just going to delete these instances afterwards, but it just makes things a tad easier. So let's go for US West 2. Click OK. Now you notice here you have the ability to choose the type. I recommend strongly that you take a look at it because I think the default database is something like $700 US a month, which I could in theory run for this since I'm going to destroy the instance right after it's done. But I'm going to choose standard for this and just use the out of the box defaults. And honestly, for most applications, this is pretty simple, especially for our contact application. And there's a cost of $10 a month. If you want, you can drop this down to, I think, 1 gig. There is a way that you can get it. Oh, if you go to basic, you can drop it down even more to like $5 a month. And that just uses 5 DTUs, which is usually enough, or at least for everything that I've seen so far. Now we're done. We're going to click review. It's going to kind of give us an overview of everything that we've done, and click create, and that should give us the database. Now the database takes a little bit longer to create. I mean, everything else was done in a couple of seconds. This takes anywhere from a minute to 3 minutes, depending on whether or not I please the demo beings right now. So I am going to switch over to our development environment for us to be able to kind of interact with the database. So let's go with our here. Now, normally you could open up SQL Server, SQL Server Studio, or Azure Data Studio, or something like Visual Studio with the integration, or Writer has Data Grid. There's so many tools to connect to your databases nowadays. I like to keep everything inside of one if I can. So luckily, Writer has the ability to do that for me, and I can do it one of two ways. Hit new data source and then choose Azure SQL database here, or I can actually use their Azure Explorer and do it now. So I'm going to do it this way just to show some of the commands. So it's going to want to know the server name. So let's go back to our web page and grab the server name. It should be done by now. Almost done. And it should really be SQL. Oh, it's done. Look at that. So I'm going to go to resource, and we're going to keep this tab open. So let's copy this out, which is our server name. Go back here, that here. And it's going to want to know the user ID, which is that, and copy out password. And look as I paste a bunch of dots in the password field. And paste that. And then I'm going to want to choose the contacts database. There's a limitation with the drivers that's used here. It doesn't allow you to go switch between master and contacts relatively easily, or basically switch between databases on the same server. I'm going to click test connection to make sure things are good. And you'll notice here that I got a message that might be hard to see, but it says the specified database user password is rejected. Then the message says cannot open server requested by login. Client with IP address 72 blah 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 is not allowed to access server. To enable, go to Azure to fix it. If I do this through the Azure Explorer, it allows me to automatically add it. If you do it through the Azure Data Studio, it also allows you to do that, but I did it through here on purpose to show you how to make those changes on the portal. So as soon as you go back to the SQL Server database portion, there is a item here called Set Server Firewall. So I'm going to do that, and I'm going to actually zoom in a little bit just so you can see a little bit better. There's a button here called Add Client IP, which is what I'm going to do. It throws a rule here that says client IP address, when it was added, the start and end. Depending on your organization, you would add a set of IP ranges, and that's your public-facing IP address. This is my public-facing IP address. So what I like to do is just name the role for it is. So here we're going to create a local role for this IP address, which is mine. This allows only requests coming from this IP range access to the servers. Now, typically you would click save, but in order to save a step later on, there is one other option I want to do. So there's a setting here, allow Azure services and resources to access this server. I'm going to click yes here. This ability later on when we have our API to have it call Azure, have it call this database. By default is locked down and only allowed to access what you configure. So let's click save here. It's successful. I'm going to click OK. Let's go back to Writer. Click OK to try it again. Oh, I probably need to give it the password. It only saves the password once there's a successful login. Let's try it again. Hey, what are you doing? So when this happens, I tend to kill it and come back and re-add. So let's get our server name right. Oh, wrong window. I did hit save. It has my IP address. So let's go back to the database, get the server name, and then let's paste you in here. Oh, I didn't put the right server name in there. And then pick my username, let's copy out the password. And contacts. This is one of the reasons why you tend to script out using something like Terraform or Azure Resource Manager to script out your resources. I'm showing this more of how you actually do it, so you know what happens when things break. So now we got a little check mark. It was successful. I click OK. And it's going to go through and see I have nothing here. So the first thing we're going to do now is go and copy off, or basically create our database. So for that, I am going to pop off to a different screen to load some SQL scripts. Now, normally you would make a backup of your database, and then restore it here. So in this case, I am just going to run them all. Let's choose the context database, Control All, play. All the database tables were created. Now we are going to create our users. Ignore the password. Like I said, these resources are going to get destroyed right after this. So it doesn't really matter that you see my password is password1. And there's really nothing in here anyway. A SQL login for our application called contacts user. And now we're going to give that user the permission to access the database, which it's good. And now last thing for us to do is create some seed data. Again, this would be if you backed up your application or backed up your database and transport it here, but since this is just a demo, I'm creating everything manually. So now I create it. So now we have Azure data. If I go here, I can do a select star from contacts, and I should have, I think, 4 items or 5 items here. Myself, Brady, Jane Doe, and Brian. So we're good to go. Now we need to send off our applications up from locally, or at least the source, to Azure. So let's go to our API first. And with our API, we are going to publish it. So depending on what tools you're using, you can use FTP deployment, you can use Azure deployment if you're using Visual Studio. There's a right-click publish. In most cases, you do not ever want to right-click publish. Because of time, we're going to do it right from the IDE, but ideally you'd be using something like Octopus Deploy, GitHub Actions, Azure DevOps pushes, but here I'm showing you how you can do it from your IDE. So in this case, I'm going to choose right-click, publish, and then publish to Azure. And this gives me the ability right in the IDE to publish it, give it any name I want. And then you have the app configuration database saying use existing app. It's going to look at my current Azure credentials and see what apps. By default, it doesn't load any. That's for performance. Click refresh. And it should show me. Did I log out of my Azure account? Yeah, I logged out of my Azure account. Give me a second. I have to re-sign back in. I have to grab my phone. Oh, maybe not. I just needed to refresh it. So now if I go back to the Azure Explorer, I should be able to publish to Azure. And now it's loading them all. This will take a second or two. It's essentially behind the scenes running their API calls. And as you can see, I have quite a few of these. We're going to want the LAA-API app for this. I could choose open in browser after publish, which will launch the URL for this. I don't want to do that right now because there's some configuration that we need to do on the server side. So let's click run. What's happening behind the scenes now is it is building the application, which it just did. Now it's creating a zip file. It's going to update the zip file. Typically this takes 10 to 40 seconds depending on your internet connection. It usually does it in the first attempt, although lately it's been doing it on 2 attempts. And now it's done. And I can click on this link to see it. We're going to do the same thing with the web. And then that's going to be pretty much it for the IDE work right now. Let's choose publish. Excuse me, published Azure. And let's choose the law web app. Click run. Now, if I ever want to republish those things from here, I can just choose these publish shortcuts up top where I would normally run the app. Once they're done, we're going to want to migrate the settings for the application. This one is done. So let's just take a quick look at the API settings. This one only really has one setting that we need to migrate, the contacts database SQL Server. So let's just copy that text, go back to Azure, and let's go to the API. So way down here, we have a configuration setting. This allows you to manage your application configuration. If you're using web, think of this as your web.config. If you're using the classic version of the framework, if you're using .NET Core, think of this as your app settings. You can also use app settings, but this allows the portal administrator to be able to overwrite things and not developers, which is what you typically would want, because this would have, these sensitive connection strings. So here, I'm going to enter that. Now for the value, it's going to want the connection string that you would set for your SQL Server. So let's go to the SQL Server. There's a connection strings tab here. You can click show, copy and paste this text and put it in there. However, mine is slightly different because I don't want people connecting with my administrator account. We want to connect with the user, with the contact user we created. So I am going to paste in that. As you can just see, the only real difference is we're using the user ID of contacts user and the password. So I click OK, click save, click continue. That's going to require a restart of the server. You see here, successfully updated app settings. Now I'm going to launch the site, and if I got everything correctly, I should be able to navigate to it. So let's open you up in a new URL, and that's fine because we don't have anything at the base of it, but we have under contacts. If I got this right, we should see the same JSON that we got before. So now this is all hosted in Azure, as you can tell here from our URL, API Azure websites.net/contacts. So now we need to configure the web app. The web app takes a little bit more work because it needs some more settings. So let's go and do that. Need to add a new application setting, and let's do settings.api URL. Good thing is I've done this demo a couple of times, so a lot of the settings are already there. Now you don't have to copy and paste too much, although I will be going off screen. So this one just tells us where we're getting the root of our API from. This allows us to do local development, non-local development. And then we want, this is for the blob storage. We're going to leave this one blank for now because we need to create the containers, which we haven't. Another app setting, this is for the name of the container, and this is where our images are going to be stored. And then the last is the URL for us to return. This is essentially the container URL that allows us to have access to the images. So we should have 4 settings here that allow our application to run. I'm going to click save. Continue. And if I run the application now, you'll see we'll be able to get to one piece of it. So I'm going to click Overview, open you up in a new tab. It should load fine. Let's put you over here. If I click this contacts, we're going to get an error because when we click contacts, we try to access the blob storage container, which we don't have. So let's go and create one of them too now. So I think we're done with the SQL, so I'm going to go away from that. Click New, type storage account. Now, blob storage allows you to create and do a couple of different things. So storage account allows you to store things called blobs, which are essentially just gigantic files. You can use Azure files, Azure queues, and/or tables. We're going to use the blob storage, which just allows us to throw a bunch of images in there. And it's a really cost-effective way to store images. Can only contain lowercase numbers, must have between, oh, you can't do dash with this. So we're going to create LA storage, West US2. Standard or premium for this, we want standard, but if you click here, you can see the difference. Standard is essentially what you'd want from most. If you're hosting a high performance e-commerce site, you probably want premium. We're going to use the second generation of storage. And then for replication, we want locally redundant. Hot or cold, hot means more instant on, cold or cool is used for like backups. Click review and create, and then click create. This takes about 10 seconds or so for it to create in the background. Once it's done creating, we're going to go to it and create what's called a container. Container you can think of as like a file folder on your operating system. It allows you a place to just throw stuff into. And they say it's object storage, and it really is. You can put anything in there, files, data, images, whatever you want. You can see the four basic options: containers, file shares, tables, queues. File shares allow you to do something like a cloud drive or a Dropbox kind of thing. Tables allows you to do non-relational database. Think of it as DocumentDB. It's essentially a key value store, and queues is simple queuing. So we're going to go to containers, and then once this loads, create a new container. Once this loads, we're going to create a new container. Here it goes. Click new, and then not give it my wife's name. She wouldn't be happy if that was the name of it. And this name should match the name that we put in the configuration file. You have three different options. Typically, you would want private and then control it using your integrated access manager within Azure to control permissions. We're going to do blob anonymous read only because we want to just have our images served in a read-only mode from the browser. So I'm going to click create. Now we have our images here. Now typically this is something you'd want to do off screen. Now that we have the connection here, we want to be able to get access to it. Because we don't have enough time to kind of cover how you can do it with the access control IAM, we're going to use the older method called access keys. So normally I would pull this off screen because you don't want anyone to see what the access keys are. So I'll be really quick about it. And again, I'm going to delete these resources afterwards. So if someone wants to use it right now to upload a bunch of images, so be it. Now we're going to go here, and we have to tell our application what the storage account name was. So that's this setting here. I am going to hit edit, paste it in there, click OK, save, continue. Now, if everything is working correctly, when this is restarted, which it is, I should be able to refresh the application, hit contacts. Contacts should load. And then we're going to upload an image. And let's choose browse. And let's see, what image am I going to pick? Let's do my DevReach podium pick. Click upload. And there's the gigantic image of me with my cool laptop at DevReach in Bulgaria. And that's it for the Azure vacation of it. But let's double check it's not all smoke and mirrors. So I'm going to go back to Writer and show us that it's there. So let's go to storage account. And then look for that storage account, which is lost storage. There's the new contacts image I created. There is the new image 21.jpg. 21, in case you didn't notice, was the ID right here. And it was created at 1:40 a.m., which was 1 minute ago my time. So I'm going to download this to see if the image was what we wanted. Click downloads, click OK. Open this up, and now we see we just downloaded one at 1:41. Open it up, there's the image of me. So now we have a fully hosted application in Azure in under 40 minutes. That is all I have for you. With 3 minutes to spare, get my contact information up on the screen again. If you want to reach out to me, feel free to contact me on Twitter, on Facebook at josephguadagno.net, LinkedIn, Joseph Guadagno, my webpage, or my stream. If you're interested in some of this content, I stream 3 times a week, typically Monday, Tuesdays, and Wednesdays, but I also have a YouTube channel with all the recorded videos. That's all I got, gentlemen. Are there any questions or anything that pop? And there's a giant cat running across the screen. If you're talking, I can't hear you.
Sorry, I was muted.
Yeah, sorry, that was my bad.
I can't hear you guys.
Thank you, Joseph, for... Hello, can you hear me?
Now I can hear you. Yes.
Yeah, thank you very much for this awesome presentation. I understand it's 1 in the morning, 2 in the morning at your place.
Yeah,
thank you for the commitment.
1:43.
1:43. that was an awesome presentation. Anybody who has questions, you can just ask it in the chat. Meanwhile, I was wondering, on behalf of the students, is Azure offering free resources for students?
Yes. There is, let's kill the PowerPoint slide for a second. There is, if you go to there's a special URL for students. I think if you go here to azure.microsoft.com, there is, under support or partners, there is a way to do it. Where did you go? Pricing. Here's a student. There are over 45 different resources that you can get for free on it. Where's the student one? I know there is a separate student pricing. You get essentially, I think it's $100 US a month for free. If you have a Visual Studio license, here it is, student developer resources. So azure.microsoft.developer.students. And then there's a start free and talks to you about, what you get out of it.
Okay. Yeah, that's good for Azure to have. So here you go. If there's any student watching, you can start developing and maintaining, developing your apps and using Azure. So no questions. Well, if there's no question, we can end it short here for Joseph to catch up some sleep, because I know he has another presentation coming up in a couple of hours.
In about 3 or 4 hours.
Debugging tips. Yeah, you get a chance to catch up on some sleep, Joseph.
Okay. Well, thank you, gentlemen. It was a pleasure. I'll see you again in a couple hours.
Thank you very much.
Thank you.
See you.
Ciao. See ya.
Bye.
Bye.
So we'll be taking a 15-minute breaks and the next session. So
Yeah.
I'm going to hang up and sign out now.
Joseph, don't. Yeah, sign out, please. Thanks.
So we are back live. We are now with Nayer. Stish, can you tell me a little bit more about Nayer?
Hello, everybody. If you have lunch, if you're having lunch, bon appétit, and we are welcoming Nayer, a friend of ours. How are you, Nayer? Long time no see.
I'm good, and you?
Last time I saw you, it was at the conference, I think. What have you been doing since? Hello?
I think we lost Nayer for a little bit. Maybe his internet is down.
Nayer, can you hear us?
Yes, I can hear you.
Okay, good. Yes, I was telling you last time we saw it was at the Women Tech Conference.
Yes,
I think.
yes.
What have you been doing since? Testing Kubernetes?
Well, different stuff. Working on different stuff. Kubernetes,
Good.
Internet of Things at home.
Good. Me too. I have been trying Kubernetes for a while with Ish and the guys. It's a good software. It's a step up from containerization. This way, it's fully automated. Well, what are you going to talk about, Nayer?
Well, so today we are going to make a basic introduction on Kubernetes and how we can do it on GCP platform. Because GCP already provides lots of high maintenance settings, so we can just leverage on GCP a bit on that.
That's good. That's good. Is this for beginners, intermediate? What type of audience are you targeting?
Well, right now it would be mostly beginners and intermediates, because I'm not going too much in details. It would be just an introduction on how to start things, how to have your system up and running all the time.
Okay, good. So awesome. I leave you to the floor. You can start by.
So welcome to this talk. Yes. So be it a nuclear catastrophe or just a system admin tripping over the cable, system admins have only one worry, is that the website should always be up. So this is what the talk is going to be about, how to never let your website go down. So a little bit about myself first. So I'm a DevOps engineer at Providus Technologies Limited. So I have previously worked as a game and web developer, also as Linux system administration, and I've done research assistant at the Uniciti Mauritius, where I have done some data analytics for some projects. And also as a hobby, I develop Internet of Things solutions. So like you can have smart homes and make your lights turn on automatically when needed. So I'm currently working at Providus Technology. So it is a gaming company where we have clients from abroad who can outsource projects to our company, and we develop that for them. So before we go forward, a little disclaimer that this is going to be a demo. Like we cannot include 5 years of experience into just 30 minutes. So I'm going to take some shortcuts into making the system so that it fits for 30 minutes. But if you need more information or something is not clear, you can always contact us at Providus Technologies. So first of all, what is our objective? But what we want to do is to have our application be replicated and our database also to be highly available, so that whenever one of them goes down, you can still get your application delivered to you. So step one is how we are going to set up Kubernetes engine on Google. So first of all, we need to create a project in GCP. So we create a project. You can see that on GCP, you can press new project, and then you will have your project created for you to see. And then after we do our project, we are going to create our Kubernetes cluster, the famous Kubernetes cluster. So we are going to use Terraform to do that. Terraform is a tool which allows us to write not codes, but like a JSON-like structures. So what we are going to do is create a Google container cluster. We are going to name it devcon GK cluster, and we are going to, and you see that why do we have a location for the Kubernetes cluster? Isn't the cloud just magic? Unfortunately, Santa Cruz does not exist, neither does the cloud. So a Kubernetes cluster on Google is actually hosted on different sites. So you can have Asia, Europe, Australia, North America, and US. But each of these, they are split into zones. So the first column here is the region, and the second one are the zones. So let's say attack. So you can still have Europe or other countries where you can still have your service up and running. So what we have chosen here is we are going to host our Kubernetes cluster in Europe West 1. Why have we chosen this location? Because it is closer to our clients. So if you are going to create your cluster, you have to make a ping from where your clients are, and then you can see which one gives the best result. And you can see that here we have Europe West 1, but if you want to make it a zone, like not highly available, and then we can go specify into B. Like Europe West 1, it has BCD, it has 3 zones spread across Europe West 1. And once we do that, we create some servers on our cluster. So we name our pool, we choose the same location as begin, and we tell him to create one server. And we also choose our machine type. It can be medium, small, depending on how much you need, but we are going to go by the default right now. And if how do we run it? So you can see my Terraform script is like this. So the GKE, so we have the Google cluster, same as before, and this, just these two, and we run it using this command, Terraform apply. So by doing this, it is going on your project, and it is going to create your cluster for you. If you click on it, you can see that it has created your Kubernetes cluster, but you see that it has created 3 machines for you. Why is that? Because it is going to create 1 machine per zone. That okay? So what we have done so far is that we have created 3 servers on the internet. But you don't see anything. You don't have your application or nothing running. So the next part, what we are going to do, we are going to create a Java application on Docker. So how do we do that? This is going to be a simple Java application, which is going to just reply, this is a response onto the root path. Okay. So we create our Docker file. We're going to use Open JDK11. We copy our Java, and then we compile the Java, and then we write the command to run the Java application, Java test. And we build it using this command below. Docker build Providus backend 01. So again, let's show you how it is inside this one. So you can see we have just these two files, the Java file, and we have the Docker file, just these two. And how do we create let me show you this. So we run this like that in this folder, and it builds your Docker container. So now in the next step, we are going to push this how do we hide this thing? Yeah. So the next part is going to push it onto Docker backend. So we just write this command here. So it is pushing. Okay. So now you can see that on Docker Hub, you have this created. Like our image has been created on Docker Hub just by using these two commands. So right now what we have done so far, so we have only pushed our code on Docker Hub, but how do we run it? It is just an image on Docker Hub. So now we have to write codes, Kubernetes files, to make this code run on our servers defined here. So we deploy our application. So once again, we create our Kubernetes file, main.yaml. I can show you here itself. Well, so on this one, we are going to create a container which is going to listen on port 80, because most web services are on port 80, and we define the name which we have chosen previously, which is on docker hub.io. So by default, it is going to fetch the images from Docker Hub, but if you want, you can also put your own custom Docker repository here. And what we are going to do is put a label on the pods. So we are going to call it app label, and we just kubectl apply the command. So what it is going to do is fetch the image from the Docker Hub and make two instances here. As you can see that we have said that it is going to make two replicas. So we have two pods running on our machine. So let me show you on GCP how it appears. So you can see that we have workloads, we have backend deployment, and we have two pods running on that. But again, you are at home, so you still cannot view the result of the application here. So what we are going to do, we have to create an ingress. So an ingress is a load balancer. So before we create an ingress, we have to create a Kubernetes service, like an internal load balancer to Kubernetes. So what it is going to do, we create a service, a backend service, which is going to listen on port 80, and also it is going to forward on port 80 and connect to the backend on port 80. And then this is the interesting part. It is going to create an ingress. So it is an external load balancer. And it is going to forward all the traffic it receives from port 80 onto the internal load balancer, which we have called backend services. So we'll just run this command. And you can see that your ingress has been created. How it looks like. Oops, here. So you see it has the address. So you can now access the address on the internet, and you have your response here. So till now, do you have any question on? Is it okay so far?
If we have any question, if anybody has any question, just ask it in the YouTube chat. And once the presentation is done, we will do a Q&A in here. Don't worry about that. Okay?
Okay, so I continue then. Well, so what we have done right now, so we have our pods running onto the backend. We have our IP created here. And you can connect to the IP and access the servers backend. So this is the response. The application is live, and you can see that if you go on service and ingress on your GCP service, on GCP platform, you can see that it has created backend service and also the ingress here. And it has also created a load balancer, or that automatically by just that one simple command. So now what we are going to do is create a database now, because applications most of the time they have to store database, they have to store data. So once again, we are going to use Terraform to create our database. So we create a Google SQL database instance, database size, and also we set the availability type to regional here. And once again, we just type Terraform apply. So you can see Terraform, you have the database here. So this part here, when you apply it, it is going to create a database on GCP. So you can see that you have your instance created for you by that command. So what we have so far, we have, so on our database nodes, it has created two database nodes actually. One is in master and one is in slave. So both have empty databases. So we want to create a user to connect to the database. So how we do that? Still a Terraform config file. You can see here. So we're going to create a user called devcon app, and it's going to connect to the same database, and we set the password here. Usually in production database, in a production environment, we're not going to set this here. But just for the sake of demo, I put it that you can set the password here. So when you do that, you can see that it creates the user for you automatically. So if you click on database here, you go on users, and you have your devcon app user. And next part, so now we want to populate the database with some tables. So we are going to create a table name called department using Liquibase. So before we go into Liquibase, so Liquibase is like Git for codes, is like Git for databases. Most of the time when developers are working, so you write your codes a certain way, and then the database has to be upgraded to match the codes. For example, if you have a department, you want a name, and afterwards you want to add the address field inside a table called department. So you will have to do it in 2 steps. So the developers would have to write their code, and then the database administrator has to upgrade the database and then tell the developers to push their code back online. So with the Liquibase, you can just write XML files, which is going to tell Liquibase that I want this table to have this field, and it applies the changes automatically to the database. So what we are going to do is we are putting our XML file into a Docker file again, into a Docker image. So we are taking Liquibase Postgres, which is a Docker image. We put our host, database, and username, password, and we copy this my changelog. Let me show you how it looks like for the Liquibase part. So we have just 2 files, my changelog. It is in this file that you can add changes. If you want to add more tables, you can write table department, you can write company here, like so the more you add this, and the more changes you can have. And yes, and the second file is just to copy this changelog file and put it into a Docker image. Okay, so this part, so once again we run by this thing here. Yes, so we compile our database, our image, and the same command here. Docker Group, yeah, on here. So now it creates an image called layer DevCon database version 1.1. And if you want to push it, with Docker push, we push the image, it is going to Docker Hub automatically. Okay. So what have we done so far? So we have just put our database image on Docker Hub. So it is not yet applied on any of our databases. So how we are going to do that? So what init containers do? So before running your backend pods, you can tell Kubernetes to run this pod first. So it is in this that you can make Liquibase update your database as required. So once you run this, you can see that inside your database, you would have your department table running. Okay. So what we have done so far. So when this is going to run, it is going to create the table here. And it is going to be a post-replicated and master and slave. But if we want to upgrade the database further, like you want to make a new release, you have to say the next time that you are going to use inside the Kubernetes file that later you want your application to be 1.1 and your application and your database to be 1.2, and you just apply it, and it is going to apply the changes and your application will be running in no time. So now we are going to see, let's say our master database goes out of service. So we still have this one here, which is going to take the place of master, and our pods will continue to run on it. And the second scenario is this server goes down, so Kubernetes is going to automatically migrate the pod into this one, and also the database connection is still up, so the user is still going to be happy with this. So that's the end of the presentation. Yeah, so if you have any questions, feel free to ask. And yes.
Thank you very much, Nayer, for your presentation. So unfortunately, Stesh isn't online right now to feed his cat or something. So yes, I have some questions here. So do you have to use Terraform to deploy the Kubernetes cluster to Google Cloud? No?
Not at all. Let's say, for example, no. You just go on Google Cloud. You can go Kubernetes engine, VM instances. No. Kubernetes engine clusters. And you can just create your cluster here.
Okay. And Chitesh, have you gathered any more questions?
Hello guys, yes, let me check if we have any questions.
And also, yes, okay, let me continue on the first one. So you can create it using the interface here. So you can create create CLI. So you can also create it using this command, gcloud container create. So you do not have to, if you don't like the web interface, you can use the command line interface, and if you don't like the command line interface, you can use Terraform. Yeah, the advantage with Terraform is that you have a versioning of what is happening. So you can just one system admin or a developer just going on the system and start creating and deleting, and you don't know what is happening. With Terraform, you have this ability to put it into Git, and yes, everything is versioned correctly.
Nice. Look, Julia is here. Robert, they are giving you compliments. I didn't know you were working at a gaming company. That's so cool, man.
Yeah, but I don't do game. I just do the infrastructure part here.
What are you guys working on currently? Can you share a bit?
Well, so our next speaker, Stefan, is going to talk more about what we are working currently. But yeah, so it's something very exciting, and we're also getting into 3D games and so on. So
on what platforms are you developing?
Well, I think it is Unity, but I'm not sure. I have to check with the developers for that. So I'm sure Stefan would be able to better answer you on the development side of things.
Development? I mean platform like only Android, PC, PS4, these kinds.
Well, it is mostly web-based.
Web-based.
Web and also,
okay.
Yes.
Good.
But also we can have mobile applications. Yeah, it is in the pipeline to have both.
Both. That's nice. Okay, so just a reminder, you guys in watching us on YouTube, you have any questions, do not hesitate. You can ask it here, or like Nayer has put out on the screen, you can email him or connect with him on Twitter. We can finish here. Owen, do you want to ask anything?
I'm good too. Thank you, Nayer, for the presentation.
Thanks, Nayer. Kubernetes and how it can help system admins and so on to limit their downtime. Next up, we will have Rengen. People know him as Thanos. Thanos will be in the house. Prepare yourself. It will be in 30 minutes at 2. All right, so he will be talking about polymorphism. I will try to get in touch with him. Meanwhile, signing out with Neil. We'll get back online. See you in 20, 30 minutes. Good, guys. See you.
There is a core belief at the heart of Liquid Telecom. The belief that every individual has the right to be connected. The pursuit of this vision has seen us build the largest independent fiber network in Africa. From Cape to Cairo, we are connecting more of Africa. Liquid Telecom, building Africa's digital future.
21C Skills is our learning platform which we've designed to help Africa's students, startups and developers gain skills that they need to succeed in the technology age in the 21st century. 21C Skills has been built for the African tech enthusiast.
It's about empowering kids to get the necessary skills to compete at a global level. Let them use their imagination to create their own companies, to work for other companies, to be part of the gig economy, etc.
21C Skills for me means eyesight. You got to have very qualified people train us through video, and we also got to have highly interactive labs that challenged me.
Take the 21C Skills program, put a lot of work in it and time in it, and it does pay off.
We're SD Worx. Nous sommes SD Worx.
Consider it done.
Teamonite.
To disrupt is to disturb. To disturb is to unsettle. To unsettle is to dislodge. To dislodge is to challenge. To challenge is to reshape. To reshape is to play. To play is to create. To create is to invent. To invent is to innovate. To innovate is to succeed. We caught up with Managing Director Michael Shapiro and asked him in 120 seconds or less to tell us all we needed to know about synthesis software technologies. It helped that he was on a treadmill.
Who is Synthesis? Let me tell you in 120 seconds, starting now. Synthesis is your ultimate technology partner. We live and breathe innovation. If you're looking for us, don't look anywhere near the box because we're so far out of it that we hardly remember what it looks like. We haven't forgotten that technology is all about people. Our team is our family, and we live by the adage that culture eats strategy for breakfast. We employ over 150 people. We have offices in Melrose Arch and Sandton, and an office at the foot of Table Mountain in Cape Town. Our tickets are booked for Mauritius, and as soon as COVID allows, we'll be set up on the island. True story. Our focus areas are intelligent data, cloud, academy, labs, regtech, digital, MSP, payments and crypto. Our technology partners include AWS, Confluent, Cloudflare, HashiCorp, VMware, Thales, and soon to be announced, Salesforce. Our client base includes enterprise in the financial services, retail, and healthcare sector. We are proud to stand alongside South African banks as their technology partner, to name a few: ABSA, AFGRI, Afrasia, Capitec, Discovery, Investec, Nedbank, Sasfin, Standard Bank, and Woolworths Financial Services, done in alphabetical order, not to offend. Our growth rate is 25% every year for the past 15 years. We launched the data science and engineering practice based on machine learning and AI principles. Our payments and crypto area is providing a world-first technology with Halo. Our MSP team stays up all night so that our customers can sleep peacefully knowing their support is in good hands. We're on track to become an AWS Premier Partner, fingers crossed. We're proud to give back to South Africa and work with partners, Africa Ticket and Girl Code, and run a hackathon with gender-based violence to define us is to lose the essence of who we are. We believe in our people, we believe in our clients and their business. In 120 seconds, that is Synthesis.
Synthesis Software Technologies always gives you more. That's who we are in 127 seconds on a treadmill.
There is a core belief at the heart of Liquid Telecom. The belief that every individual has the right to be connected. The pursuit of this vision has seen us build the largest independent fiber network in Africa. From Cape to Cairo, we are connecting more of Africa. Liquid Telecom, building Africa's digital future.
Skills is our learning platform, which we've designed to help Africa students, startups and developers gain skills that they need to succeed in the technology age in the 21st century. 21C Skills has been built for the African tech enthusiast.
It's about empowering kids to get the necessary skills to compete at a global level. Let them use their imagination to create their own companies, to work for other companies, to be part of the gig economy, etc.
21C Skills for me means eyesight. You got to have very qualified people train us through video, and we also got to have highly interactive labs that challenged me.
Take the 21C Skills program, put a lot of work in it and time in it, and it does pay off.
And so you're live for our session with Vangan. Stesh, tell us more about it.
Yeah, welcome to the presentation. We have Hannes in the house. Hi your horses and hi your wives. He's going to talk about something which sounds very, very complicated. It's called polymorphism. How are you doing, Hannes?
Okay, I'm fine. And just to correct you, polymorphism, I'm just going to tell you it's not complicated. Just some people like to make it look complicated so that we can look intelligent. It's a problem of our society here. So I'm here to demystify the concept of polymorphism. And one of the reasons of that talk is that I've done interviews for a long time in my life. I have given interviews also. And there's a question of polymorphism when it's being asked to me, or when I ask a question, I often get the wrong answer. And even when I give the definition of polymorphism, when I'm being interviewed, the interviewer just look at me and said, it's like he's hearing something that he's not expecting. So the purpose of this talk is to explain the concept. It's not difficult. It never was difficult. It's just people misunderstand it. So most people think that there's only one form of polymorphism. And the only reason they think so is because they only education system. People are not trained to read or to train their mind. And one of the purpose of this talk is to make people to rekindle the interest in computer science. Learn algorithm, learn about type system, learn about these things that are very important because they are coming in programming languages. Languages like Rust and Go, they are modern languages that are, and they are encompassing all these modern how to say that, those modern concepts in computer science. So you need to learn those things and you need to know those things. And that is why it's so important. So I have shared my screen. So the next part, when you Google polymorphism when you Google polymorphism, you're going to mighty Wikipedia. This is what you get. And it's very hard to read that thing. I mean, this thing is for PhD people. Now, what is polymorphism? It's a very simple concept. It's a one function that can take multi forms of data. This is what polymorphism is. This is what it is. This is what it was always about. One function, many forms of data. Now, most people just think that, why should I care about polymorphism? Even the person who asks you the question, what do you understand by polymorphism? He doesn't even know why you should care about polymorphism. The reason you should care about polymorphism is that polymorphism gives you correctness in your code and gives you flexibility. Now, this may seem like an oxymoron. No, it's not. You can be correct and flexible at the same time. This is the power of maths. This is the power of the type system being given to you, and you should be able to use it. So let's go to the next slide. So the known polymorphism, the subtype polymorphism, that's the polymorphism most people talk about. The inheritance mechanics that you have in OOP languages like Java, C#, Kotlin, and so forth. Subtype polymorphism is the most popular one. It's the one that most people, when they ask you about polymorphism, this is the answer they're expecting. Then you have parametric polymorphism. Parametric polymorphism is quite old. It's in the 1970s, mid-1970s, in F systems, in an algebra or calculus, if you want to call it that, called F system. It goes way back, almost 40 years. But most people don't know it as parametric polymorphism. They know it as generics. That's because of C++. Now, here's another one, ad hoc polymorphism. That came into 1990s, early 1990s, 30 years old. Then there's another one, higher kind of polymorphism. What comes in the end of the 90s? Then there is row-type polymorphism. This is when you start to hate yourself. You see all this polymorphism, row-type polymorphism, you say, what is that? Then the last one I just read about like 2 weeks ago, parametric effect polymorphism. This is where I ask myself, and for those who understand that, this is, but I'm trying to say this is very, very advanced form of polymorphism, and it may come into standard programming in 30 years, or maybe earlier on. I just hope it's come earlier on. So in this talk, we're going to focus on the 3 most popular polymorphisms, the subtype, the parametric, and the ad hoc. I would touch a little bit on higher kind of types, just a little bit, just to give you an idea what it is. So, subtype polymorphism. So, in subtype polymorphism, you also call it inclusion polymorphism. That's the name that many people use in the language theory or type theory, something like that. And it's popular in many OOP languages like C++, Java, C#, and so forth. And many people associate this form of polymorphism to inheritance. It's not. Inheritance is a mechanism. It always was a mechanism that gives you polymorphism. It should not be considered as a feature. It's a mechanism, but as usual, people concentrate on the mechanism instead of concentrating on the main ideas. This is a plague in our industry. For example, when you ask what is OOP, object-oriented programming, most people would talk about classes, objects, child object or parent classes, or whatever garbage we want to sell you. But the idea behind OOP is messaging and polymorphism. If you don't know that about OOP, you fail OOP 101. And this is why I'm trying to tell you, people should concentrate on the main ideas and not on the mechanics. Concentrate on the bigger picture, not the mechanics. Okay, this is more or less what I just said. Okay, inclusion polymorphism is just what, if you have a type A, what is a subtype of a type B, then all the values of type A is also of type B. So A is a subset of type B. So, and that's more or less what I've just said. So now, as usual, we'll look at the demos and examples. So I have subtyping here. Let's look at the usual suspect. I think most people have seen this kind of this kind of demos in the past. Just so I'm using the language Scala here, just so not to be afraid. I have a trait is like an interface. It's not exactly an interface, but for the time being considered as an interface. And a case class is like a class, except that many little functions are being used or being generated for you by the compiler, like the hash code, the toString, the deconstruction of the class, and that kind. Normally we use it just so that we can avoid to do new, and that's all there is to it. So, and you have your classical abstract class. That's a class that you cannot instance directly. You need a concrete class, but these are things that you are used to. Everybody who's done Java, C#, they are used to that concept. I'm talking concept here. I'm not, forget about the syntax of the language. Okay, here I have like your basic food types. You have earth food, you have plant-based food, which extend earth food. You have the grass, blah, blah, blah. You have banana, which is a fruit. You have golden apple, you have apples. Let me check where all the apples. Apple. Yes, this is apple. I should have put space here. Then these are your classic hierarchical of classes. Okay, then you have your oranges, meat, and blah blah blah. And I have done another one for animals. The same thing you are used to. You have an interface called animal. Then you have something called a fish. Okay? And a fish takes a food type. Then you can have like a fish, a concrete class of fish called tilapia. And who asks himself when the fish dies, he says, "Côte bonne faute." I asked myself that also. And you have the white sharks. So also here, when he died, he said Joe's movies were bad for us. Then you have sea mammals. Okay, then the dolphin says don't come here to Mauritius. Then you have the blue whales. They say they don't exist in Mauritius because people did not see them in Mauritius. And then, as you can see now, I have animal who is an interface. Now I'm just adding another method called drink, because fishers don't drink, actually. And I had added a method called drink to the earth mammals, and I have other forms of animals. So these are things that you are very used to, and you can go crazy about that. And here is a herbivores, but extended wild animals, and you know what kind of stuff. So the monkey would just say, if going extinct, before we say going extinct, the monkeys, you have different. So you know about all these things, and you've been doing that for years. For many, many years, people have been doing that. Now, what is the problem with that? Let's say I'm trying to have like, I will talk about it later on when we do generics. Let's go back to the presentation. So all these things like animals, subclassing, you are used to that. And these are things that people do all the time, with subclass, another class, and they do that all the time. So what's the problem with inheritance? Well, you have a yo-yo problem. What's a yo-yo problem? Is that every time you go in with hierarchical thing, you have to go back and forth. Oh, what does meat means? Meat is an earth food. Where's earth food? You have to go up and say, you have to go back and forth between the definition of the classes and the parent classes. But if you have the code, if you don't have the code, you have to look for the books and look for the hierarchy in some other mean. Okay? So this is the first problem you have with inheritance. Inheritance breaks encapsulation. I'm sorry to burst your bubbles here, but inheritance does do that. This is why you have the protected keyword, because it actually broke the encapsulation. And now you have to have access to the parent class variables, and this is where encapsulation gets broken. And it gets worse if you are trying to do multi-threading with locks. Try to do what we call a transaction between two accounts. At some point you will find yourself exposing your locks if you're using locking. This is how bad it is with inheritance. I mean class in general. So with inheritance, you inherit unnecessary methods. Most of the time you have methods that is defined in some classes, and you don't need them in the concrete classes or subclasses. You don't need them, but they are there, so you have to use them. For example, there are some definition of queue, who is a subclass of a list. Now, a list, you can traverse a list. By definition, you should not be able to traverse a queue. But some people will say, okay, a queue is a subclass of a list. Now you have like map method and all these kind of methods which pertain to the list. Now the queue must have it, but the queue doesn't need them, because the queue you can only access it either at the beginning or at the end, depending on what kind of queue you have, an NQ or a DQ. So you are inheriting methods you don't need, and you break encapsulation on that, and you also break your main idea of your classes. Now here's the last part. The problem with classes is that it's open-ended. anybody can take your classes, like in Java, C#, and other languages. You can subclass them, and you get that for free. And the problem is you get it for free, and that's why people mess these things up. Newer languages like Scala free, Kotlin, classes are closed by default, so as to prevent the abuse and overuse of inheritance. These are the problems with inheritance. So what are the solution? Well, the classic textbook, it says, prefer composition over inheritance. Prefer interfaces over inheritance. But with interfaces, what you do, interfaces is not inheritance per se. Inheritance just say, I guarantee that I have those methods. It's a contract that you expose. In many languages like Go, Rust, they don't have inheritance anymore. Too much problem arises because of inheritance. Other languages like the newer ones are like diminishing the power of inheritance. So they go for interfaces. Now, this is something that is not very familiar to many people, called sum type. Okay, a sum type is like, how do you say that? Is that you know all the different subtypes of your type. Let me give you an example. Normally I don't like to do live demo, but here I forgot, I think, to do. So for example, I want to create an option class. I'll just say trade option T. Then now from this I would just say how to put the plus here. I will explain later what the plus means. Case class, just say let's case object. Case object none. Then I have case class of like sum of T, which extends like this is an example of this is an example of a sum type. All the subtypes of option are known. People cannot create another form of option. Think about animals. You can create only a set of animals. People cannot create other forms of animal except on the one you have defined. It's like an enum. You can either be none or not or some. In an enum of colors, you can have like 7 colors. You cannot be more than any of those colors. So this is what the sum type means. It means that you can only be one of either of those values. And the product type is your classic record, where a field, when a class can have multiple values like a name, an ID, an age, something like that. So this is basically what sum types and product types are. And together they form something what we call algebraic data types. And this is preferred. Languages like Kotlin, Scala, Rust, TypeScript, they are making you like, not forcing you, but they are making you like, they are promoting those kinds of data types, sum types and product type. When you use inheritance, if you have to use it with reserve. Use it with reserve. And by default, make your classes final, class, or seal. Just like many languages do it by default for you, because they don't trust the developers or the programmers. Now, here comes the second form of polymorphism I was talking about. This one is called parametric polymorphism, also known as generics, unfortunately. Templates, more unfortunately, because of bad garbage called C++. It's popular in languages like Java, C#, C++, Scala, and many more, like the ML family, the Haskell, the OCaml, the SML, and Go. Go 2. Google are finally seeing the light. In Go version 2, we're going to have generics or parametric polymorphism. Finally, Go have seen the light. I mean, Google have seen the lights. Unfortunately, most people use parametric polymorphism or generics in collection, and they mostly use it in collection. Surveys have been done. Unfortunately, this is where it's being used, and it's sad. It's very sad to see people not use that kind of power in their code. So what is parametric polymorphism? So you can make your function or your data type generic over data types. And you can think of a data type, which is a parametric data type, like a function with a parameter. Let me give you what I'm trying to, let me give you an explanation of what I'm trying to say. For example, this seaweed does not take any other type parameter to create a seaweed. It doesn't take anything as parameter. For example, I cannot create none just like this. If I create like an example, I cannot create blah, blah, blah. Let's go to some I cannot create sum just directly. Okay, I have to put a parameter here. Ah, sorry, I forgot to say something here. The problem here is that the type inference is going to infer the type for me. Yes, the type inference infer the type for me. So automatically in Scala, you have something called type inference. The int is inferred for me, but I cannot create sum just like this. Okay? You cannot create sum just like this. And you should not be able to create it, because sum takes another type to be able to create sum. You need another type. Okay? So this is what I mean by a type like in generics or parametric polymorphism. Your type takes another type, just like a function takes a parameter. This is why it's called parametric polymorphism. It's a type that takes another type as parameter. Hope you get it. So, I mean, to continue on the same idea, a generic or a parametric type can become concrete only if you parse it the other type. You cannot have a list. You can only have a list of integers, a list of strings, but a list on itself doesn't exist. Okay. So why is it so important? So you can code algorithm irrespective of type now. It's only at the very end, if somebody wants to have a sort algorithm, he can pass an int, he can pass a person class, he can pass over data types, then the concrete version will be created, and you do not have to concentrate on the algorithm. So you cannot say that, okay, now I have a sort for integers, a sort for float, a sort for person, which people in Go are actually doing. For men, they are copy pasting and changing the type parameter every time. I've seen some of the example, and people are in the Haskell, Scala community make fun of the Go developers, unfortunately. So why would you use generics also? You would avoid doing casting. So if you have, like in the old days of Java, you have a list of objects. And if you wanted to have a list of person or a list of animals, every time when you take an object out of this list, you have to check for the type, but cast it to the right type. If you have a list of animals, you have to cast whatever you pull out of the list, cast it to an animal so that you can use it. But now with generics, you don't have to do that. The compiler does that for you. And the other one is what the famous do not repeat yourself. You got the gist of it. So now example. Let me check. Yeah. So I already gave you an example about parametric polymorphism. Look at this function. Remember earlier on I told you with polymorphism you get correctness and flexibility. Imagine a function that can take any type and return you the same type. You might come with the idea, okay, I can write, there must be like infinite number of functions to do that. In fact, this is not true. There's only one function in the whole world that can only take one type and return you the same value, the same type. And that's the identity function. There's only one function that does that. No other function can allow you to do that. This is what the correctness and the power of polymorphism and parametric polymorphism gives you. Okay? Then, this is another example of where you can pass any data of type A, then you convert it to a toString. That's very simple. Then where you have this one, this is a wrong example, but you get an idea of what I'm trying to say here. Here I'm going to pass a value, which is of type, can only be bounded by numbers. This is called bounded types. I will come to that later. And with that, you will only take that value and you will get the double of it when you will add 1 to it. No worries about bounded types. I will come to that, and this is the next part of my talk. Now, here comes the problems with generics in modern languages like Java, C#, and so forth. Generic on their own are very simple, but you mix it with subtyping. This is where just shit hit the fan. But I would say in French, cacophony. Now, there are 3 forms of variance. Invariant, covariant, and contravariant. The contravariant, this is where you ask yourself about many questions in life, like because it's that mind twisting. Okay, in invariance, you don't care about subtyping. You don't really give 3 shits about the subtyping. You don't care. Then you have covariance. A covariant, simple. If B is a subtype of A, then the container of B is also a subtype of A. Very simple. This picture says it all. T. S is a subtype of T, so the list of S is a subtype of list. Let me show you that in that example I wrote before. Okay. Remember that plus. In Scala, this is how you write covariant. In languages like Kotlin, you will write it like, I think it's called CIL also in Kotlin. CIL interface, then you write option. This is how you write it in Kotlin. Covariance called out and in, just like in C#. In fact, the guys on Kotlin said they took those naming convention from the C# community. And there's a very specific reason why it's called out and in. The reason it's called out is that most of the time when you are using it as a output variable, you use the out. When you are trying to have an input in a function, like an input parameter in a function, use in. And in is, in generic parlance, is called the contravariant. There's a very specific reason why it's like this. So for those who are wondering what is nothing, nothing in Scala and Kotlin and other languages, nothing is called a bottom type. Just like in Java, you have object which is at the top type. In Scala and Kotlin, we also have one thing called the bottom type. It's called the nothing. And I think in the theory, it's written in the type theory. I think it's written like something like this. This is how they write the bottom type in like in type theory. So just for info. Okay. And let me give you another example of covariant also. Let me check if I have non-generic list. Okay, this is also written some non-generic data type, but to tell you how difficult it's going to be to write non-generic values. For example, this is a non-generic list. You have to do int, then I have to do string. I have to copy paste that and change it, the value to string, and also change the name of the class and object. So same thing for tree. I missed that part, sorry. And this is how you would create a generic list. Of course, the A must be covariant because a list of monkeys is a sub-list of animals. Just to give you an idea. Now, let me go to over stuff. Now I have the variance. You remember when I wrote the fish and the other animals, I had to pass a food type. Now, let me talk a bit about covariant, then I will go back to subtyping. Okay, sorry about the mess up. Okay. Okay, this is an example of covariant, and this is an example of contravariant, and then both. Okay. Okay, let me go back to that so that I don't miss. Sorry about that. Sorry about I missed the things. So there's something what we call bounds in generics. Here, as you can see, animal can take any F as long as the F is a food. So for example, animal will only eat anything of type food. You cannot pass anything that is not food type. Reducing the scope of what type of F I can pass to animal. For example, for fish normally eat fish food, unless it's in a fish farm where they give dead dogs to them, and humanity should pay for that, what they are doing to the fishes. So the fish only eat fish food. So of course you would not be feeding the fish a dead dog or a dead cow or a dead monkey, because the fish only eat other fish food. Same, for example, a tilapia will only eat seaweed. Any form of seaweed here, here's any form of seaweed. And shark will eat other fish. So shark will not eat seaweed. So this is how, using bounds and parametric polymorphism, you are making your program more correct. You're not passing the wrong parameter to your classes. And the compiler will complain if you pass the wrong value, the wrong form of food to those white shark or tilapia or whatever. So this is the same thing what was written in subclass, in the subtype packages, but it's rewritten in the generic type, so that to give you more control, more correctness on your classes. I can do the same thing for fruits. And I have a bunch of them. I've written a bunch of them. I would put it on GitHub so that you can go and work on them. For example, here monkeys only eat fruit. You cannot give a dead dog to a monkey. You cannot give dead chicken to a monkey because the monkey only eats fruits. You can give bananas. You can give apples to the monkey. Same thing for the giraffe and the elephant. So by doing that, you're making your program more correct. And the compiler is your friend. Very important. Your compiler is your friend. So now you have that. And let me go now to talk about covariant. So now I have explained a bit about bounds. So in covariant, as I said earlier on, the parameter is always in the output. So for example, here I have a covariant. For example, I have a class called covariant that only takes fruit, and it's covariant in its argument. So now I have a covariant of type apple, and I'm saying that fruits or one is what this relationship holds. This relationship holds because this is apple is a subclass of fruit. I can make it work. Now let me try to do that now. Compiler is complaining. I cannot put golden apple in a Granny Smith. For example, I have a box. I can only take Granny Smith. I cannot put a golden apple in it. Compiler says you have a type mismatch. Don't be an idiot. Correct that code. So the compiler now is your friend. You will not get runtime error. You don't need tests to check for that. All these guys who do TDD, well, we can have a fight later. Now, let me go to that. We have contravariance. This is the part where it's like mind-binding, like you're in the matrix. If B is a subtype of A, then the container of A is a subtype of container of B. It's like mind-bending. It's like the arrows are reversed. It's like now this is where the part is also saying why the spoon is bending. T is a superclass, but yet a list of T is the subclass. It's like it has been reversed, and this is contravariance. So let me show you what contravariance looks like. Of course, in Scala you put a minus. In languages like Kotlin you will put in for input parameter. Forget a bit about this one. I will explain what this one means later on. So here, if you want to change a fruit, you can only be in contravariance position. You cannot be in covariant position as it is an input variable. You cannot be over on that. So example, you have like stranger. I did have an example. I think I must have removed it. So an apple can be contravariant. This is okay. You can change it. You can only put over apples now. Let's try to put something like a. Let me check, but I will do that later. Let's just say I have an apple here. I've also put I can also put an apple. So any subclass of apple can be put in it. Now let's try to do something like contra 04 new contravariant. Now can I put a banana? In my box of apple, I cannot put a banana in it. That's because compiler says, nah, no, you dumbass, you're putting a banana in a box of apple. You can't. And this is the power of polymorphism and parametric polymorphism. The compiler is becoming your friend. Now, there is one little problem with when you try to mix both contravariant and covariant. Remember, you can only be covariant in your output argument, and you can be contravariant in your input argument. But what if in that case you have both? You have a getter and a setter. You cannot be covariant and contravariant at the same time. This is the part where you choose to be invariant. You say, fuck what, you're going to be invariant. These are some of the cases where you are actually invariant. In fact, common wisdom is to be invariant by default. You only choose variance when you have subclass, lots of subclass, and you want to be true in your domain. You want to be true that you can only put apples in box of apples. You don't want to put oranges in box of apples or bananas for that matter. So this is a summary of what covariant and contravariant is. Upper bound, I've jumped the guns a bit, but you get the idea. So an upper bound will restrict the types to which the subclasses can be bound to. Okay, I will go a bit quicker now before the guys start to hit on me. So there's much more restriction you can put in generics and when you have subtyping. You can have bounds. You can have multi-bounds that is very well used in the Kotlin and Kotlin ecosystem. Existential types, that I won't even talk about it. Type projection in Kotlin, self-type, and you have many more. I don't have time to go through all this, but you have sufficient material to go look into it. Sufficient materials to go to satisfy your curiosity and look for it. And you will make you a more intelligent person, a more productive programmer, a more correct programmer. So there's one little guy called F-bounded type, and this is a part where most people would start hating themselves. So this is an F-bounded definition. Where is it? Yes. I've taken that example from a very good developer called Bob Norris, and he gave that in one of his blogs. It's so well done that I don't even dare to not name it, not to take it as it is. So I have a pet. A pet takes a parameter and it can only take a parameter of type pet. This is a part where you ask yourself, where it's really mind-bending. And this is where you will use it. Have a fish pet would only be a pet of fish pet, and when you rename that fish pet, we can only return you a fish pet. If that thing was not in that form, you can have it return anything you want. This is another example, a record. You can use that form to create a small ORM for yourself, just to have fun of it. And you can create records in databases. And this is our example how we can create records in a database. We can create your own small ORM to do that. Okay? Now we'll talk a little bit of higher kind of type before I go to the main part of the talk called higher kind type classes. Higher kind of types is like an abstraction over a type which is self-abstract over other type. It's like abstraction over generics. Okay, let me give you an example. Higher kind of types. Okay, you have all these types. An option of A, a future of A toss of A fiber of A, an either string, which can take either a string or some parameter, whatever you want it. You can have a list of A, array buffer of A. Would it be nice if we could abstract on all these containers? Would it be nice if we could abstract on those? Well, many languages like Scala, Haskell, Idris, and so forth have it. In Kotlin, we have an emulation in the tremendously good library called Arrow. We have an emulation of higher kind of types using some weird techniques that I won't talk here. So here, this is an example of a higher kind of type. I have a functor, but abstract over the container. And the container says, okay, I can have a map. I can have a map. And the map, I have a container of map of a container of A. I have a function matrix and A returns a B. and returns me an F of B. It returns a container of B. You can rewrite it also like this if you like that kind of style. Then this is an example of a list. This is a functor of a list. A functor takes a list, then you can apply a map on that. Then you have, and this is a very simple example. You can, and from there on, you can abstract upon the containers itself. This itself will take like many days to explain, but I'm just giving you an idea of what it is and what's out there. Now to the big one. You have something called type clauses. It was created in the early 90s. Here's a paper. The paper is here. It's an approach to ad hoc polymorphism. It's very popular in the functional programming community. It's becoming more and more popular in popular languages like Go. Go 2 is going to have it. Kotlin with the KIP 87 is going to have it. C# 9 will probably have it. So you have to learn that shit. So type clauses in the early 90s was designed to solve something called the expression problem. I don't have time enough to explain what it is, but you get an idea of what it is. You have you can add what it basically means is that you can add functionality to a type, but what type you don't have your hand on it. You don't have you have the source code for the type, but you want to add functionality to that type. I want to add the functionality to a string, to an int, to a float, but I don't have the source code of float or string. And this is where the power. This is what's called ad hoc. I can add method. I can wherever I want, when I want, where I want. It's like wherever, whenever, like Shakira says. It's a bit different from extension function. And type clauses is like a group of type which satisfy contract defined interface. So this is very different from extension function. Type clauses obeys the contract of the methods are existing in interface. So a type clause consists of two things. It's a type clause definition and instances of that type clause. The main what we won't be talking here in this talk, type clause derivation and qualified types. I don't have time for that. So where does type clauses and interface differ? I mean, they both define behaviors. They both have instances. Where they really differ is that interface, you define the behavior inside your type. While in type clauses, you define it outside your type. This is where the power comes from. You are able to define it outside the type. So a demo here. Type clauses. Let me give you some operations. Okay.
Just a little reminder, and then you're running out of time.
I will just do that and ask the question. Okay. So I'll just do that in 1 minute. Okay. This is a form of a type clause. I define all the different methods I can do in my class. Then I forget about this one. Then I create an evidence. An evidence that I have both definition for string. Remember, string doesn't have duplicate, doesn't have a toInt, doesn't have a cat definition. When I define an evidence, this is where I do the thing outside of the type. I create an evidence. Then, for example, here I have this method called print things. In Scala, the way we do type clauses is through implicit. And this is how you can add operations to existing type to which you don't have the control upon. You can add function, you can also add other members to that type. So this is it, and okay, type clauses, generation, how kind of type they work together, especially in the FP world. And okay, let's do a Q&A very quickly if I have the time. Hello?
Okay, so yes, Yug has asked the question. If you could improve polymorphism, what would you improve?
The PhD of people are already improving it. So I don't have to improve polymorphism. Polymorphism just means one function I can control multiple sets of data. and you have so many, and so many may come or may not come. Question I can answer. I'm still a student in the field. I'm not a professor in the field. Okay?
Okay, good. He also thanks you for this very interesting talk. It was a very intense talk, I would say. A lot of people have been wondering what they have failed in their life recently.
Yes, Kotman Footy. Yeah, I know. And yes, if you have any more questions, I'm going to answer those. I can do it very quickly.
If you have any question, guys, just type it quickly in the comments because in 10 minutes we have a next speaker coming up. Otherwise, you can contact Rangan through his Twitter.
Yeah, my Twitter is, no. I have used Cornell there. For those who don't know, Cornell is the Superboy's name in the new 52 kind of thing. So I use my Cornell, Rangan Cornell. Okay.
Rangan Cornell. Rangan's our local superhero. Anyways, man, thank you.
Okay, as you can see in my Twitter, there's this good friend of. That's great.
Yeah. Okay, great. I'm going to contact the next speaker again. Time's up. Just sign out.
Signing out.
Let's go. So we are
Hello,
ready,
guys.
Bob? Yep, we have our next speaker here. Chitesh, do we want to introduce him?
Yep, our next speaker is Dennis. He's a senior developer advocate at Couchbase. He's going to talk to us about NoSQL. Hello, Dennis. How are you?
Guys. Yeah, thanks for having me.
Thank you for coming. So, can you tell us a bit what the audience should expect from this talk?
Sure. So, well, I go to a lot of conferences and talk to a lot of developers, and I still think that, for me, it feels like the majority of developers have a limited experience with NoSQL in general, and they quite often don't understand the whole system or what's happened the past 10 years. And this talk is essentially a conversation about, hey, if you ever meet me on a conference and you ask about NoSQL, that's essentially what I would like to tell you about. So 10,000 feet overview of what's happening in the NoSQL, why we got where we are, and what are the problems that we have.
Okay, good. Yes, I know some developers who locally are trying NoSQL. I hope they are in the chat right now. So what we are going to do, Dennis, you can start your presentation, and whatever question the audience might have, just type it in the chat box. After the presentation, we are going to do a Q&A with Dennis. Is that good?
Yeah, okay, thank you very much.
Awesome. So, good luck, man. Bye.
Yeah, thank you. So, hello everyone. Thanks for being here today. I am Dennis. My name is Dennis. I work as a developer advocate at Couchbase. For those who never heard about Couchbase in the past, Couchbase is a NoSQL database, fairly similar with MongoDB, but designed for highly scalable applications in general. As I mentioned, I felt this need to talk about NoSQL in general, just not about a specific technology. This is not the usual kind of talk that I give, but I like to talk about the ecosystem in general. And when I think about the architecture of modern CPUs, it's kind of mind-blowing to realize that roughly 85% of the CPU is actually memory, and 1% is dedicated to CPU. So this is a fairly old, 12 years old CPU, and you can see that everything that is inside the green lines are memory. And even when we go to a more modern architectures, so here is a quad-core array, it's pretty much the same. So the majority of the CPU is actually memory. And why we have such architecture? It is because of one problem called latency. So latency is a big issue in computer science in general. And as you can see, the farther you get, the latency increases dramatically the farther you get from the CPU. And the problem with latency is that this is a very tough problem to solve. Quite often, to have just milliseconds or nanosecond improvements, you have to come up with new materials, new technologies, and invest potentially millions of dollars just to have a very small increase in performance. So one of the things we have been doing what we have been doing the last 20 years was essentially, instead of improving latency, we start to increase the bandwidth. So we start to parallelize stuff. So now we add more cores, we add more parallel memory instead of just improving the performance of the memory itself. And if you think about it, that's essentially how we have doing with application with our applications in general. We have distributed databases, we have microservice. So we try to distribute the application in order to make this in order to improve the throughput of the application itself. And that's essentially one of the problems with SQL in general, relational database. So say you have two tables, right, user and role. If those two tables live in a single server, well, life is beautiful. When you are joining the two tables, it is in general super fast. So it will, as long as your tables are properly indexed, each join should cost you around like just a few milliseconds or microseconds, in fact. But then, if you when you need to scale out your database, some problems start to appear. So, for instance, let's say you add a second server, and then the traditional way to solve this is to add a replication. So essentially, you replicate. You always write to the server 1, and then you replicate, and everything is replicated to server 2. However, this replication, if you make this replication synchronous, then you have to write to both servers before you commit the transaction. Or if you make this replication asynchronous, then you might end up with some dirt reads on server 2. So let's say you wrote to server 1, but you read nearly the same time, the same column or the same line from the same row from server 2. So you might get some dirt reads. But then if we try to make instead of replicating, if we try to make the relational truly distributed, then we end up with something called cross-node join, right? Because when I'm writing a join, like I make a query and make a join there, I might end up selecting stuff that part of the data is on server 1 as part of the data is on server 2. And because this is a cross-node join, and the data has to travel over the network to make this join, it will take your query will be super slow because of that. Again, another problem with latency. So, the question that I always receive is, will my favorite relational database be distributed in the future? And my answer is, hey, do you even want that? Because relational databases, they are great for what they were designed for, to run in a single machine. At the moment that you try to force those relational databases to run distributed, you start to break the design, and then that's why even though most of them are like 20, 30 years old, they still don't run distributed. They barely run distributed, to be honest. So that was a problem that Google and Amazon had roughly 20 years ago. And back then they were using Oracle, I think, and they were hitting some limits on Oracle as well. And one of the problems with Oracle and Teradata and some other databases is that they quite often they rely on specialized hardware. And for Google, Oracle wasn't hitting the scale that they need, so they decided to say, hey, how can we create our own database that runs just on commodity hardware? And then a few years later, both Amazon and Google published two famous papers called Dynamo from Amazon and Bigtable from Google. And one interesting thing on the Dynamo paper, for instance, was that, hey, instead of using tables, they decided to use a different data model. So they decided to group the things. In this case here, I'm using JSON as an example. So because they organized the data differently, so instead of here, I would need at least 3 or 4 tables to store the same kind of data. And because I'm storing data as JSON, in this case, I can save this in a single document. So what they realized after re-implementing this whole thing was that roughly 70% of the operations were just by key values, operations, because you don't need any joins anymore. And then 20% of the operations were returning a set of rows, and only 10% you actually need some kind of join. And well, that's really great, because when you are doing that much joins, it doesn't matter where your data lives in the cluster, so you can make a fully distributed database. When you change the data model, you also make your application less transactional. So for instance, let's say I need to insert this user, right? In a relational database, I need to insert it in the user table, start the transaction, insert in the user table, insert it in the user roles, insert preference, and then commit a transaction. And of course, managing this transaction has a cost to the database. When I'm inserting like a different data structure, like JSON again, inserting the whole user is just a single operation. So I kind of don't need a transaction for that, because it is already a all or nothing operation. I would just need transaction when I need to, let's say I need to add 2 users at the same time, then it's a transaction. But the use cases for changing 2 documents at the same time is already like much smaller than just inserting a single user or a shopping cart or those kind of things. So they were able as well to reduce the need of transactions, which remove a lot of overhead of the database. So essentially, after those 2 papers, we had the big bang of NoSQL databases. Pretty much all the NoSQL databases nowadays came after those 2 papers. And that's exactly, and then 10 years have passed, and that's exactly what I would like to talk today. So what happened in the past 10 years? So if we assume that everything, I am not a big fan of this NoSQL term, because it essentially defines everything that is not relational. So if we assume that NoSQL is everything that is not relational, we have over 200 NoSQL databases out there, according to DB engines. But relational is by far the most popular type of database, which seems to me that we are still overusing relational database in general. And then, of course, followed by document stores. So document database like Couchbase and MongoDB, they are the closest you can get from relational. So they are as well the second most popular type of database. One thing that is important to highlight for me in general is even though the original papers were talking about scalability and to run distributed, not all NoSQL databases will be distributed. Again, we are talking about everything that is not relational, and this is a very big group, so you have all sorts of database there. And again, not a distributed database. If the database is distributed, that doesn't mean that it is highly scalable. So in some scenarios, the database were originally designed to run up to 20 servers, let's say. For instance, let's say you have the database has a master-slave architecture. So MongoDB has this kind of architecture, where your application always talk to a master, and the master will talk to the slaves. One of the problems here is that when you need to get your data, you have just you need at least 2 hops, right? So your application talks to the master talks to the slave. But on the flip side here, there are a bunch of features that are very easy to implement. So for instance, if let's say your document has 5 foreign keys, and you want to check if those foreign keys exist or they are valid, the foreign keys, the master has the list of all the IDs in the database. So once you send a document to the master, he can quickly check and validate if all those foreign keys are valid. But the problem here, of course, is you have a single point of failure. So if the master dies, you have your database will be unavailable for a certain period of time. And yes, of course, you can add more masters, but it just becomes a little bit complex to manage that. and still the master will always be a bottleneck. So when you have a different kind of architecture like Couchbase and Cassandra, for instance, where we have a masterless architecture, which means that there is no difference between nodes, and your application has to talk to all nodes. Essentially, the application can guess where the data is by hashing the ID of the data. But in this case, you can scale to hundreds of nodes without any major issues. So just to give an idea, a rough idea, so in Couchbase, in theory, our limit is 1024 nodes. But roughly, I would say no client has reached anywhere close to 200. So we do have clusters with 100 nodes, but that's pretty much the max that we can get. That clients are willing to create. After that, they decide to create a second cluster. But the problem with this architecture here is one, it is more highly scalable, but one is more difficult to build a database like that because it is a truly distributed system. And second, if you want to store a new document and you have to validate your foreign keys, it will be more cost expensive here because you will send the data to one of the nodes of your cluster, and this node has to maybe make 5 requests asking other nodes if this key really exists. So there are definitely some trade-offs according to the architecture you choose. So, for instance, MongoDB, in my experience, the sweet spot is something around between like 5 or 6 nodes. After that, things get a little bit complicated. While like Cassandra and Couchbase, I think that's far easier to have like 20, 13, or 15 nodes running. One of the characteristics of NoSQL nowadays as well is all the distributed NoSQLs, they can handle failure quite well. So in general, you might not even notice that the one node have failed because they usually have copies of the data, or just parts of the data that will be unavailable for a short period of time. So that's one of the advantages of NoSQL in general. They are already a database that were born, they were almost cloud native. So handling failure in those databases are usually quite easy, and it's not a big enough headache in general, like in the relational world. NoSQLs are also less bureaucratic nowadays. I personally believe that one of the reasons why NoSQL is less bureaucratic, so we have like flexible schemas, we kind of trust whatever the developers send us, is because I think that when relational databases were created, the team responsible for managing the database and the team responsible for developing the application, they were different teams. So you need some sort of contract between the application and the database, and then you also need to revalidate everything. In the NoSQL world, we already assume that, okay, if your database is saying something wrong, that's a bug with your application. We don't want to waste time revalidating everything. It's your responsibility to send the right data for us. Our responsibility on the NoSQL side is to write and read the data as fast as possible. So in general, they have much more flexibility in the schema and handling with data in general. I'm not a big fan of, as I mentioned, NoSQL. This term NoSQL or NewSQL or NoSQL 2.0 kind of feels like some marketing guy is trying to define some new training terms in technology. I prefer to call databases for the real categories, In case you are not aware of some of them, key value stores are essentially big hash maps. So you insert data by the key, using the key, and you get data by the key. So DynamoDB and Redis are essentially key value stores. You can also use Couchbase and I suppose MongoDB as key value stores as well, because to build a document database, you have to build a key value store first. Document databases, essentially you store data as JSON, and you can still query and create indexes and pretty much everything that you do with relational. It is the closest you can get from relational. So again, MongoDB Couchbase fits here. Columnar storage, Cassandra is essentially when you need a more global overview of the data. So it's really good for when you need to group data and count and aggregations in general. A graph database, we have Neo4j and TigerGraph. We also had like TinkerPop, which is a spec that I suppose the Cosmos DB support TinkerPop, and also Giraffe, which is not being used anymore that much. But essentially, on the graph database, you would use a graph database when the relationship between entities is more important than the entity itself. And we also have search engines, so Believe, Elasticsearch, Solar. So you essentially need to use this kind of database when you need to do some smart text matching. And time series, like InfluxDB, which is when time plays a big role in your data. So let's say you need to plot the graphs or analyze the graph of the stock market prices. So time is very important here, and that's exactly when you should use consider using a time series database. One thing that I like to highlight here is that most of these databases are more than 7 years old, and this is really important because I do think that for databases in general, it takes a while for them to mature, and they are all mature piece of softwares. I like to compare with database with aircraft engines. So aircraft engines also, even though you come up with the most magnificent kind of engine, it will still take at least like 7, 8, 10 years for this engine to be commercially available. And that's pretty much, I would say, with databases in general. They take a while to mature. And because they have been out there for a while, pretty much all the tools you need are already there. However, of course, you won't be able to use your favorites tools with essentially all the tools you like to use with a relational, you won't be able to use with NoSQL, but we have, in general, similar tools that are good enough. And this is still one thing that we have to improve in NoSQL, which is have more integrations with third-party tools. So here are the big guys, essentially. So the open source guys, those are the most famous databases out there. So MongoDB, Elastic, Cassandra, Couchbase, InfluxDB, Neo4j, and Redis. So if you are considering using a NoSQL database, that's essentially one of the guys one of the databases you should consider. And when we talk about cloud providers, then we have naturally DynamoDB, Cosmos DB, and Firestore, respectively from Amazon, Microsoft, and Google. And this is essentially how they are current. I'm referencing here the Forest Rave, and this is essentially how they are distributed nowadays, which are the most popular, or what are the current offerings of those databases. Cool. Another important thing to highlight here is that pretty much every month we have new NoSQL databases out there, and quite often they mention something called storage engines. So storage engines are essentially early stage database. So it's pretty much like a framework that manages the files for you. So that's the storage engine is responsible for writing the data to the disk. And in general, new databases will, instead of creating their own storage engine, they will use someone that is already well established. So for instance, CockroachDB started with RocksDB, which is this blue one here. So they started using RocksDB, and then in the first few versions, and then after a while, I think last year, they moved to their own storage engine. So pay attention to this, because whenever you probably don't want to use a storage engine from someone else, because you need to create quite often you need to create a specific storage engine for your use case. So whenever you see a database saying that, hey, we use this storage engine or that storage engine, and they were not the ones who created it, potentially the database is sub-optimized. In general, I would say that starting with NoSQL is very easy nowadays. So pretty much all database vendors have a very good documentation. And I would say you can roughly go from novice to advanced in somewhere around six hours. If you have already the right materials, you potentially only need like 40 hours or so. So that's very easy to start with. There's no need to be afraid. But still, what I learned over the years, and I think that the database community learned over the years, was that developers were not afraid of using NoSQL database. What they were really afraid of is how do I maintain that? Like, what should I do when something goes wrong? And DynamoDB was the biggest example of that, because when it is a NoSQL, so-called NoSQL database, but if you see the adoption of DynamoDB was incredible, because hey, if I don't want if I don't need to manage the database itself, it's not a big deal. I can use that kind of database. I have seen even people using DynamoDB in the wrong scenarios just because they didn't want to manage the database by themselves. And all the NoSQL vendors kind of noticed this trend, and I would say that pretty much all NoSQL providers now have their own cloud offerings. So Couchbase has one, Elastic, MongoDB, DataStax, and Neo4j. They all have their offer of database as a service. There's also another trending topic right now, which is running databases on Kubernetes with operators, which essentially helps you to achieve something similar to a database as a service. And this is exactly my talk on Friday. So guys, if you had time, please watch this talk. It's called Database on Kubernetes, Why You Should Care. It is essentially one of my favorite talks. And then we also need to talk a little bit about the problems with NoSQL currently. One of the main problems for me is that the databases are converging in general. So you see things like, okay, Postgres now allows you to store JSON, right? So there is a new query language. And then I have seen people on the conference say, hey, you don't need NoSQL anymore because Postgres allows you to store JSON. And well, no way. There is ages of difference of the support for JSON on, let's say, MongoDB in Couchbase versus the support of JSON on Postgres. Or Couchbase, so like support transactions, MongoDB offers a standalone mode, even though it is designed to be a distributed database. DynamoDB is starting to add some small capabilities to query data. Many other databases are also trying to be operational and analytics at the same time. So the main message here is when you are comparing NoSQL databases, if you are trying to do some box ticking, you probably will have a bad time. So don't try to compare NoSQL databases by just checking, hey, do you have this? Check. Do you have this? Check. You really have to understand the use case, right? Well, in the past, I have heard a lot like something like, okay, do one thing and do that thing well. And I used to agree with that, but I don't think that the reality works that way. So for instance, let's say I have a database and I want to implement advanced search for the back office, just to search for users, right? Because quite often you ask a name and then you don't know how to spell it properly. And then you want to be able to find some client or a user as fast as possible. And just because you want to do this kind of fuzz match in general, you have to, let's say, install Elasticsearch, configure the nodes, manage this whole environment, synchronize the data from your database to Elasticsearch just to make an advanced search on your backend for the back office of your company. It's kind of a waste of resource because you don't need that much. You don't need all this power just to implement this specific use case. So it would be nice if the database, for instance, has a full text search in it, right? Then you can leverage the structure you have in the database just to do this fuzz string matching. So, and that's why databases are kind of realizing that, and they are trying to have offer specific service with very limited use cases. And that's one thing that you should be aware of. So, okay, that's nice that you offer this thing here, but how far can I go? So you really have to spend some time understanding the database and the capabilities of each scenario. One of the things that I also hear a lot is which NoSQL database should I choose for this specific scenario? And then I start asking a lot of questions, and quite often I hear from the developer, hey, I don't know the answer for this. And it's really important to understand your scenario before you choose a database. So because there is this famous phrase from the Alice in Wonderland, where the cat says, hey, if you don't know where you're going, any road will take you there. Which means that, hey, if you don't know what you're looking for, kind of doesn't matter, right? Whatever database you choose will do the job. One of the questions that I ask is, hey, which kind of consistency you need? Do you need a serializable consistency, or is read committed good enough? And again, I think the huge majority of developers have no idea of what I'm talking about. So for instance, Couchbase and MongoDB also support read committed transactions, which is, I would say, the new trend now in NoSQL databases is to support transactions they didn't have in the past, because it's much more complicated to add transaction support for distributed databases. Couchbase has one approach, MongoDB has another. So this is one of the hot topics in NoSQL today. And really committed is essentially the same, the default consistency model in most of the relational databases as well. So if what you do if you never change that, potentially that's the same thing you will get on those NoSQL databases. And there are many other questions that you should ask as well. So for instance, how much do I need to scale? So if my nodes will be, if I just need like 4-6 nodes, then I could pick this specific database. If I need to scale to 100 nodes, then I have to go to another database. How I will query this data, how fast the queries should be, because naturally some databases have has different SLAs. how often do I update the data? So if I don't update the data that often, then I might use some database that is eventually consistent instead of using one that is strong consistent, and I get some other benefit from that. So there's a bunch of questions you should ask yourself before choosing a NoSQL database, because once you choose a NoSQL database, it's a little bit hard to move to another. It's not like relational that you can essentially, if you're using Hibernate or other ORM frameworks, you can just change your string connection and boom, you are running on another NoSQL or another relational database. Rule of thumb here is whenever you are selecting or choosing a NoSQL database, pay attention to the defaults, because they will give you a nice hint on how you should use the database. A second problem that I kind of already talked about is it's really hard to migrate from one NoSQL to another. Quite often you have to rewrite your whole persistence layer because they are not super compatible. And this is one of the issues that we are working on now. So Neo4j has opened his language to be open spec, so everybody can implement the same wide column type of databases. We have something called SQL++, which is a paper published from UCSD. So essentially, it's a language that is fully compatible with SQL, but with some extra keywords to help you use query data when you have a hierarchical structure. Just to give an example, I mean, AsteriskDB, Couchbase, Apache Drill, and PartQL already support SQL++. PartQL is an AWS database, and it is very similar to SQL in general. And if you're familiar with JPQL, you probably will understand well how it works. But essentially, you can navigate through the structure by just using dots. And the father of SQL itself is a big supporter of this language. So Don Chamberlain was one of the guys who created SQL. And he actually wrote a tutorial, a free book actually, called SQL++ for SQL users. And that's one of the things that Couchbase and some other companies are trying to push now. Hey, let's create a standard language for NoSQL databases. The last thing I would like to talk about is open source versus enterprise. So it is a problem that we still need to figure out how to handle, because if you think about database in general, I understand that we all would love to have all databases to be open source. But the problem is when you see the amount of contribution that the community make to those databases, they are essentially minimal. So the majority of the contribution comes from the company making developing the enterprise version of the database. And this is kind of one of the issues we have right now, because okay, we are saying open source, but there's next to no community contributions on those projects, apart from Postgres. I would say pretty much the other database have next to no community contributions at all, and this is something that we should expect already, because databases are very complex piece of software. So potentially, once you get into database, you potentially spend your whole career there, because they're very complex. There is a lot of theories, a lot of things you should know before even changing a single line of code. And that's essentially one of the problems we have. So last year, MongoDB changed their license to, they created their own license. Redis went the same way. Couchbase and a few others decided to stay with using the old ones. And the problem with those two, this new type of licenses, is that they add a lot of loopholes there. And one of the main motivations of this, why they changed the license, was because some cloud providers that you probably are aware of, they decide to offer manage a service of those databases without contributing to the database itself. So they just grab the database and run on a managed service, and that's it. And this kind of impacted the revenue of those companies, and that's one of the reasons why they decided to change the license model. But so far, this is licensing is one thing that we discuss, I would say, every week on Couchbase and some other, and pretty much whenever I have a chance, I also discuss this with other folks in the field, in working in other companies. And so far, things like we are, the consensus is to have a single core business model. So essentially, hey, the core for the enterprise and the community versions or the free versions are essentially the same, but on the enterprise versions you have some extra features. So Couchbase is kind of walking this direction. We are not there yet, so we still have different cores for community enterprise, but we are already changing the whole the code internally to move to this kind of business model. And there are some other companies that are already there. So Elastic already have like this single core model. And well, I hope that we should go to the same direction instead of creating specific license models, which is terrible for the open source community in general. Brief recap here. So I do think that relational databases are still overused. NoSQL is getting very easy to start with, and now we have pretty much all databases have database. Pretty much all vendors have a database as a service offer. Choosing NoSQL is will still require a lot of investigation. So before choosing a NoSQL, make sure you spend enough time investigating and understanding how everything works under the hood and what are the best use cases for each one. Because migrating from one NoSQL to another will potentially force you to rewrite your whole persistence layer. So yeah, that's some of the things that you should bear in mind right now. That's essentially what I have. I just would like to talk about 9-bit. So they are sponsors of the event and also Couchbase partners. So if you need some help with NoSQL, probably you should check out those guys. And yeah, that's what I have. I am a little bit, I'm just on time. And if you have any questions, feel free to ask. Thank you very much. Okay, so let's see if we have any questions in the chat here.
Yeah.
Okay, so we have so Firestore. Well, I'm not super familiar with Firestore, to be honest. So I don't have a strong opinion on it. What I know is that they are. It is becoming one of the main NoSQL database on Google Cloud. And what I know about Firestore is that they are, in some extent, our competitors, because Couchbase also has a mobile database called Couchbase Lite, which automatically synchronizes with a backend database. So when you have a mobile application, for instance, and instead of making a lot of REST calls to your backend application, we can synchronize. If you use Couchbase Lite and you're using Couchbase, we take care of the synchronization for you, which makes really great for databases when you need to make applications that are offline first. So, for instance, there are a lot of games that are using Couchbase Lite and flight companies, because, of course, when you're traveling, most of the apps you don't have connectivity, so it's really good for those specific use cases when you are when you need to be offline first. And it's also a free database.
Good.
Okay.
Thank you, Dennis, for the talk. I have a few questions from my end as well. I would like to ask, when do you use a NoSQL database instead of a relational one? In what context?
Okay, so I didn't want to touch this topic during the talk because it's a very extensive. In general, I would say one is scalability. So if your data grow, if you expect that the data will grow really fast. So for instance, let's say in a year, I know that a relational database won't be good enough. That's when you should potentially consider NoSQL databases, because they are the majority of them are highly scalable. What else? And of course, when you have specific scenarios. So for let's say for full text search or for time series data or columnar storage, so you need a data lake, for instance, then you go to a NoSQL database. But I think the main thing when you should consider database is scalability. So for instance, at Couchbase, this company that has as a CEO Bitten Fruit, they are heavy users. I can't say the name, but most of the products are white, and they are heavy users of Couchbase. And whenever you log into any of their products, you're essentially the data is stored in Couchbase, and in their case they have like more than 1 billion devices. So you can imagine that you can simply use a relational database for that. And that's one of the use cases when you should consider NoSQL. And as well, when you need, like, let's say you need to read from the database as fast as possible. So a lot of betting companies also rely on NoSQL in general, because NoSQL in general won't have a lot of overhead that relational database have. Okay,
understood there. So if my database is going to explode in size, that expected size in years, then we have to try NoSQL. Also, I want to talk a bit about CouchDB for the student here, for the developers here. Does CloudDB offer any? Does CouchDB offer any cloud offerings?
So good question. So CouchDB and Couchbase, they are actually different things. They were born. In fact, Couchbase was born from CouchDB. So two companies. One of the companies responsible for CouchDB joined with one of the companies responsible for Memcached, and they create this new company called Couchbase. I would say the CouchDB nowadays they barely have. They don't have a lot of traction anymore. So Couchbase really have improved a lot, and then CouchDB kind of is, I would say, falling behind. Couchbase, yes, we do have a database as a service solution already. But one thing that I would like to invite you guys is to join on my talk on Friday, where I will show you how can you deploy a database as a service in your own Kubernetes cluster. So you can hire a database as a service, but you can also have this deploy on your own cluster and then fail nodes and scale up and scale down without any human interaction. So that's pretty much, I mean, pretty much all the database as a service solutions out there are under the hood using Kubernetes and operators, which is essentially the talk that I'm going to, the topic that I'm going to talk about. But yes, long story short, Couchbase also has the best business service solution now.
Awesome. So, like Dennis says, everybody on Friday, Dennis has a slot on databases on Kubernetes, and why you should care. It's at 1 a.m. Mauritian time. Okay, so do we have any questions? No questions so far. Okay. So on Friday, Dennis, are you going to explain us a bit on some scenarios where a developer might use NoSQL and Couchbase, right?
I can talk a little bit about that, but my talk there is essentially, hey, I will deploy a database on Kubernetes, and then I will fail the nodes, I will scale up and scale down, I'll try to mess up with the database, and I will show you guys how, okay, the database will automatically recover because of the whole infrastructure of operators and Kubernetes. And the whole topic is that essentially in the near future, you will choose between running a database on Kubernetes or using a database as a service, because they will be very similar in general. So all the benefits of that you have on database as a service, you also have on Kubernetes, but with much more flexibility, because you can configure the database whatever you can fine-tune the database, while in most cloud providers, the way you can fine-tune the database is very limited. So you can just, let's say, improve the number of reads and writes, for instance.
Okay, good. If anybody have any question on or wants a full demo on Couchbase, a guy called Stephen Bird told us to contact Nasbit for that. Great. So I think we are out of time. Thank you very much, Dennis, for the presentation. It was great. And see you on Friday. I will be
see you guys.
there too.
Bye-bye.
Thank you. Bye-bye.
That's it, guys. Now, next talk that we are going to have will be by Natalia on the Winomics Cloud Lambdas micro frontend for an architecture. So we are looking forward to this in 10 minutes. See you.
You're live. So, hello guys. We do have Natalia with us. Steph, do you want to tell us a little bit more?
Yeah, sure. Natalia is from South Africa, I believe, right now. Is that true?
Sorry, yes, hello. I am from Uruguay. I think this is what you asked.
Ah, Europe.
Yeah.
Okay,
Uruguay.
okay, good.
Yeah, but
okay,
I live in Spain at the moment. Yeah.
Oh, okay, nice. So Natalia is going to show us a winning cocktail. She's a bit tight on her schedule, so this presentation is going to be 20 to 25 minutes. If you have any questions, you can maybe connect with Natalia on her social media. Natalia, I leave the floor to you. You can continue.
Okay, thank you very much. And yes, I would like to apologize because due to some unforeseen circumstances, I had to a little bit compress my talk today. But I still want to present to you this winner mix with cloud functions and micro frontends for an architecture smoothie. Again, like our colleagues presented, I am Natalia Bendito. I am from Uruguay, but conference, I would like to be there. Amazing place. I am a web and Angular Google developer expert, and I work as a principal software engineer and front-end architect for one of the largest clients at NetCentric. And I really want to keep you cool with this cloud presentation today. So if you read the outline for this talk, you know we will propose some requirements, often posed to, enterprise scale software like high performance, localization, multiple endpoints. But are those requirements only for enterprise platforms and applications? This talk will be definitely useful for developers that have not yet had the chance to work in a cloud-native setup in an enterprise context. But I believe that the ones that may benefit the most may be smaller agencies and startups trying to become maybe more competitive through their infrastructure. So what I'm going to aim at doing today is to debunk the myth that in order to leverage the amazing opportunities that cloud introduces, you need to be in an enterprise context. Like you have to be part of a large enterprise team working in delivering enterprise platforms. Let's start by asking ourselves this question. Are problems solved by enterprise solutions very different than the ones that need to be solved by smaller scale websites? And if they are, can we approximate them? Can we compare them and put them together and try to extract whatever is common to both? In my opinion, a smoothie is a smoothie. Doesn't matter the size of the cup or the flavor. And web software solutions oftentimes are or tend to have very similar problems to solve. And when we're talking about cloud, even more so. So when you finally do this migration, when you finally move yourself to the cloud and start trying to solve problems from the cloud, those differences are even less and less evident, except for the size, of course. And I don't mean the size of the solution, also the size of the team, the size of the budget, the size of the risk. When I started working as a developer in a small agency, that was way too long ago, things were super different. We had to pick up a CMS and specialize with it. In my case, or in our case, it was PHP, and it was connected to my MySQL database, or you could only connect to MySQL databases only. We had no time, we had no skills, nor dedicated resources to hook our own templates to pre-built components and modules. So usually we had to, use what was available from the community. I can tell you that I used to work mostly with Drupal, so I would go to the Drupal community and see what was available to solve my problems. And the result was usually a myriad of different, yet very static HTML output with a spaghetti of naming conventions, of patterns, of ways of doing things. When it came to styles, looked all different. There was no pattern or methodology whatsoever. So it was not very clean, and it was not very easy to maintain, and it was not very easy to understand either. Because the backend was PHP and the databases were MySQL, or had to be MySQL, we had to find adapted hosting providers. And we had to learn to use them. And I remember scouting the internet for hosting providers that had cPanel, because it was the easiest way to work, for me at least. But sometimes the clients didn't want to pay for that particular provider. They were not happy. They had another one in mind. So it was really, really challenging. And I don't even want to mention how we used to store the code and version the code and deploy the code. We simply had no advanced knowledge, and setting up all that back in the day was extremely, extremely complex. So keeping things up to date was a real challenge. Life was really tough for us at that time, and it was insecure, and it was also very inflexible and hard to keep up with, changes. If you wanted to change anything in that infrastructure that was so tightly coupled, it was almost or near impossible. But even then, problems to solve were almost identical. This is something I can tell you. So what are those layers that represent the domains of problems to solve within a software solution? No matter if it's a tiny website or web app, or it's a large platform serving hundreds of them, if it's a cloud, or if it's a horror setup like the one I just showed you, you will need to have an infrastructure set up, which are the servers, the network, etc. You also need a layer that takes care of the business logic, whether it's a classic backend or it's serverless. And no matter the size of your solution, I guarantee you will need to connect to a third-party API. And it's likely you will need to connect to several dozens endpoints. And finally, what I, as a front-end architect, consider the most interesting, the sweet topping for this smoothie analogy, is the front-end, right? The UI, or the user-facing technologies that guarantee a great user experience, return on investment for your clients, and also loyalty from your users, right? Because if they're happy with how they experience a website, a platform, an app, or any of these experiences, they will come back. But that's merely an outline. There are so many more things to solve for solution architects. You need to decide on the tech stack. You need to decide on the patterns. You need to decide on the frameworks to use, the build systems, the dependency management, the continuous integration and development, and release models. And I am not even going to mention, okay, I am mentioning already, security, performance, observability, analytics, targeting, etc. There are so many things in the scope that it becomes burdensome at times. Those decisions are also influenced by three important factors, not exclusively, but they probably have the most weight. One, it's time or deadlines, how much time you have to complete this. Money. What is the budget to support this delivery, this development? And also teams. And when I say teams, I say, I mean team size, team seniority, time zones, communication skills, leadership skills, who is leading us into successfully delivering this. And I really wanted to mention them because they should be considered very much at the time of making decisions, whether you want to, stay on premise, work with a monolith, or you want to move to the cloud. Now let's go back to the cloud idea and map all those ingredients to cloud features. I am not here to advocate for any particular vendor in this talk. There are several options in the market, and probably the ones with the largest ecosystems are the ones you see in the slide. AWS, or Amazon Web Services, Microsoft Azure, and Google Cloud, all with a set of amazing features and options and plans as well. However, in order to make references more clear, I will use Amazon Web Services products as example. So we mentioned earlier before how small agencies and startups offering software development service can really benefit and become very competitive by leveraging cloud platforms, but they need to understand very well what the free tier or the lower cost tiers for each service provider offer, because there are differences, and maybe you think, okay, I have it all covered with this plan, and then you realize you have to subscribe to more services or products. And you also, if you're in this, like if you're a person making decisions, you probably want to make sure to be offered hosting and storage, obviously, for dynamic and static apps, because static apps are taking a lot of relevance lately. Serverless computing, also known as functions, databases, and and maybe you want also, I don't know, artificial intelligence or something like this, but this is for more complex applications, for more complex functionalities. So let's start mapping the layers to actual cloud options and see what we have at our disposal. The first batch of issues we're going to solve with cloud, that is common to all web solution mixes, are those connected to hosting. And by hosting in the cloud, you have out-of-the-box access to, for example, HTTP2 protocol, right? Which it's desirable most sites or more applications move on to in the future. We are already, or we have it already available for 5 years or so, but I think the percentage of sites on HTTP2 still not 50%. And we can also forget about latency, because serving from the cloud, you are serving from a distributed network that ensures you don't face those issues. So if your user is in South America, for example, like in the picture, and you have only the servers in Europe, then this user is going to have to wait a lot of time for this data to arrive. But if you're in a distributed network like cloud is, it's going to be served probably from a server close to the user. And all cloud services offer state-of-the-art caching and load balancing, and these perks will very much increase your performance scores, right? And of course, we will reduce the bill on infrastructure setup and maintenance exponentially by not having to deal with this on-premise, including the bill for securing that infrastructure, a bill you obviously don't want to skip. When going to the cloud, we're going to leave behind those monolithic backend implementations that we're used to, and we will be more interested in fragmenting it, right, into multiple independent microservices, each one exposing its own API. We also know, or I am sure you know and you have faced this before, that apart from the services that you create, that you may develop custom to your to suit your needs or the need of your clients, your requirements, you will very likely need to integrate a myriad of third-party APIs. I'm talking about cookie management, I'm talking about maps, about user localization services, about localization services for several languages, payment, user authentication and authorization, well, amongst other third parties, right? And all of those are very likely to need to be integrated, and you are going to want to streamline all those requests. You are going to want to have them like centralized, and for that, cloud services provide API management through a single point of entry in order to organize and secure requests and responses, especially those carrying sensitive data as payload, like user information, payment information, etc. Once we have an infrastructure and network more efficient for global consumption, like it's on CDN, we have an API gateway, we have also delegated our business logic to serverless computing, and we have organized our API connections through this API gateway, we can proceed with the mix. Of course, now we have a bunch of microservices instead of one monolith architecture, and what validates this decision, right? This depends on, well, it depends if it's enterprise or not, because if it's enterprise, in my opinion, you may want to have microservices probably when multiple features of an application are developed by independent cross-functional teams, particularly when they have release cycles that are based on the need to update or continue to develop new functionality. If you're working as a unique small team, you still may want to encapsulate services and make them as generic as possible, because that will probably help you reduce time and efforts and costs if you maintain your own libraries and have them ready to plug in and reuse them across many projects. And if you have split your business logic into individual encapsulated mini backends that can be independently installed or deployed, you probably also want to have an independent front end, right, for each one of them. So each one of those micro frontends could be built with the use of a completely different front-end technology or framework. And you could have Service A use Angular, like I am representing them with colors over there, and Service B use React, and then Service, I don't know, C use Vue, and you could have them all bootstrapped to the same HTML page, of course, if your performance budget allows. Now, micro frontends are probably the fancy smoothie right now. Everyone is talking about micro frontends, and everyone wants them, and everyone thinks they're better than anything else that we've ever seen before. But let me clarify from a front-end architect perspective that I only believe this is partially true, which means micro frontends are good providing you need them and you are ready for them, right? Micro frontends don't make sense if you have a single team and components are very tightly coupled. And they may make real sense when you have multiple teams taking care of different features that map for different domains, if we are thinking of a domain-driven kind of architecture. And you have a good strategy to share commonalities between these micro frontends in a way that they are easily cacheable. Like if you have, if you use utilities or if you consume utilities that are exactly the same, you have dependencies that are exactly the same from micro frontend 1 and micro frontend 3, you probably want to remove that from each one of those encapsulated micro frontends and take it to a place where they can be consumed as dependency and they can be maintained only once. So if you package your commons and upload them to NPM following semantic versioning, for example, and are able to use them as extracted dependency, then you probably have a case for micro frontends. If you're part of a single small team and you still want to delve into the depths of micro frontends, one plausible solution would be to use a monorepository pattern, for example with Angular, that's possible, and bundle each application as a micro frontend. You also need to pay extreme attention to the dependencies, especially Node, the Node version, the Angular core version, the Angular CLI version, and probably you want to compile them all with the same compiler to avoid issues. You can push this idea further by implementing each one of the micro frontends as standalone Angular elements. So Angular elements are basically Angular components packaged as custom HTML elements that implement the Web Components API as a web standard. The browser will register each one of them as a custom element registry, mapping an instance of a JavaScript class to an HTML tag. So each one of those red squares represent an HTML tag that instantiate a JavaScript class. Each of those elements make all the required Angular infrastructure available to the browser. So as described in the code snippet you can see on top, the create custom element function creates a custom element class based on an Angular component. And what's the benefit of this? Whether you work in separate teams, maintaining multiple services independently with independent release cycles, and you work in a small team maintaining a few different client applications, for example, if you package your elements separately, you can reuse those components, you can version them, you can update them, you can install them, you can remove them and replace them without affecting the whole ecosystem of your application. Okay, so now we have a few layers under control and migrated to the cloud pattern. Now we only have to think of a content management system. Content management systems typically integrate a CRUD interface for the authors to create, edit, and delete content, an API to get and post this content to a database. So you obviously need that database as well. And finally, another API to serve the content back to the user. There are plenty open source proprietary options that can be integrated depending on the use case and needs. And one such example could be Contentful. And we will expand on this headless CMS idea in a moment. So until now, we are giving an outline and talking about layers or concerns, but let's start giving things cloud names to better define our architecture. Like I said, I am not recommending any option of cloud provider in particular because they all have pros and cons, like I mentioned earlier, and they all provide amazing solutions, and which one suits you best will depend on your specific needs. But I feel it is easier to understand cloud if we map functionalities to their commercial names, because we have heard them many times, perhaps. So I will use, again, AWS as an example and also put names to other ingredients of this recipe. This is a real-life diagram of a cloud implementation, and as you can see, we have the browser, right, that hits the content distribution network first. And in this case, we can call it CloudFront. That's the offer from AWS, where everything is cached to make it super fast. And again, this is distributed, so probably close to the user that makes this request. For enterprise scale solutions, you're also likely to find a load balancer in the middle in order to better distribute requests that go past this first cache. A bit deeper in the guts of the cloud, we find the API gateway connecting us to this myriad of microservices handled by our serverless microservices functions. And let's take the content service as an example because we were talking about Contentful and headless CMS. In this particular case, we offer the CRUD or the CRUD via an instance of Contentful. And I happened to come across, not long ago, like 2 weeks ago, somebody who didn't know what the headless CMS was. And it's nothing but a CMS that doesn't have an inbuilt front end. So you have the CRUD for the authors to create the content, to edit it, to publish it, but you don't have a representation in the front end that is fixed. You can build your own front end with whatever technology you want. So this means that the authors have an optimal content authoring experience and your front-end view is completely flexible. And in order to store this content, we set up, in this case, a Dynamo database and connect to it via a GraphQL API with an Apollo client in the middle. So in this case, our front-end is an Angular application, and we have spinned a GitLab instance in the cloud to handle atomic deployments and continuous integration pipelines that, put all this HTML, all this generated output JavaScripts and assets to an S3 bucket. An S3 bucket is basically that storage, a simple storage system where you deploy all your artifacts to. It would be rather impossible to implement all this in the few minutes we have left in this presentation, but this talk is to give you ideas and invite you to research. And there are plenty of resources online to help you get started, up and running with cloud and serverless. However, I would like to discuss a few items a bit more. First of all, one of the most interesting features of cloud is serverless computing, also known as functions. In the case of AWS, it's Lambda functions, and all main cloud providers offer editors to quickly design and implement your functions. So functions, like mentioned before, allow you to drop those large unnecessary monolith backend implementations in favor of single responsibility functions. It is very easy to scale up if you need, and if you don't need to use them, you don't need to compute. This time, doesn't represent a cost. So you don't necessarily need to pay tons of money to have serverless computing, especially when there is low traffic. So you pay for the computing time only, and this is why I believe it is very, very interesting for consultants outside of the enterprise context. If you've never seen if you've never seen a serverless function, or you don't know what it looks like any backend code of your language of choice. You can choose to write your functions in Node.js, in Python, in Java, in C#. Regardless of the language, they're written in, these Lambda functions have a handler, right? They have logging capabilities. They also have a context with methods and utilities, like, for example, in this case, content function name, which is invoking this method within the context. And finally, they have also a deployment package, which is a bundle of your function and your dependencies ready to deploy. So serverless functions can be invoked from a pipeline execution using events, using webhooks, or action rules defined in a YAML file, in a configuration file. And pipelines can be monitored and secured via roles and permissions. So for each one of these activities, you will find a service. In the case of AWS, you have CloudWatch, which is kind of a developer tool in the cloud, and YAM to define security and access policies. If you're familiar with other platform-based delivery systems, like, I don't know, the Jamstack-based Netlify or GitHub Pages, you know one of the most loved features is the continuous development and integration seamless pipelines. So you have your code, you push to develop, or you merge a pull request to develop in GitHub, and suddenly you see a build running in the Netlify console. You can totally integrate your existing repos in GitHub or even Bitbucket, I believe. I am not sure, but I think yes, probably the main providers for code hosting with most of these cloud providers platforms. So process is usually quite straightforward, and you will have all your code available, as well as dedicated tools to configure, build, and deployment pipelines. And I really, really wish I had this back in the day when I was pushing zip folders down the FTP internet pipes. So the truth is, no matter the composition of your team or what processes you follow, if you're agile or not, having a well-designed continuous integration and delivery pipeline is quite vital. I think it's one of the most important aspects of team development right now. It's especially important if you're splitting your software in domains and assigning teams to each domain, because you want to have that really in sync, and you want to make sure that you integrate things very, very seamlessly, especially if whatever is being developed in team A is a dependency of whatever is developed in team B, right? So you really need very well-designed release models. So if you want to have full control over these release models and the most control over your CDCI in the cloud, you can think of spinning a GitLab server in the cloud to suit your needs and design it in any way you want. For all three cloud services mentioned, GitLab is ready to install from their marketplaces, but you have to keep in mind that exactly because it's pre-configured, it has dependencies in additional services that you may need to subscribe with an additional cost, I suppose. So you will need SSH keys, you will need SSL certificates, you will need a dedicated domain, and relational database. For Azure, for example, you need to deploy a new virtual machine, and for AWS, you will need an additional S3 bucket for all the artifacts. But I can guarantee you, because I work in a similar context, that is very, very worth it. The most important part is that you can automate your pipeline via Lambda or functions in order to automate the publication of your packages on a certain event, for example. I don't know, you decide which branch is your base, and whenever there is an integration to this branch, everything will get deployed. The same automation process can bump versions in the context of a semantic versioning strategy. And then application shell developers only have to update the version in their packages, like in their package JSON, for example, to consume the most up-to-date release. Once you have all those very important aspects of your infrastructure figured out, you can even simplify your life by replicating environments and code as infrastructure with the help of Terraform. I say simplify because this is the goal, but Terraform is really a hot tool, but it's also a complex tool. So the important thing is to know how it may help you. You will need to figure out how to exactly use it and implement it. So you have pipelines and workflows that work for you, and you want to reproduce them. Let's say you have your development infra set up and want to duplicate it with the chance of reconfiguring it for, I don't know, UAT or for production, and even for local development, for your local developers to have a local setup. And Terraform will help you manage all that. So you will be able to share configurations, scale up and version your environments, and automate provisioning from a single management tool. So in sum, what are the final flavors for our smoothie mix? If we decide to go with cloud, we will enjoy reduced costs in infrastructure setup and maintenance. It will be much easier for us to scale up. It will be much faster to deploy. We will have 0 to none downtime, because even if we crash or if our code crashes, our functions crash, there will be no downtime. We will have absolute and complete flexibility, the ability to choose all the technologies in the stack. Of course, we will be limited by products, like we said before, but if you want to have a REST API, you can do it. If you want to have a GraphQL API, you can still have it. And if you want to have both as well, you can also decide how your infrastructure looks like. Which leads in the end to a great developer experience, since we are no longer restricted. We can spin any CMS. We can, like I use Contentful as an example, but any CMS could be a headless CMS right now, WordPress, Drupal, even the proprietary Adobe Experience Manager. We can use, like said, REST or GraphQL. We can go MySQL database or Dynamo or whatever we want. And we can choose from a whole market of third-party integrations to cover authentication, localization, and other needs. And finally, because of enhanced CD and CI tools, we don't need to restrict ourselves and our clients to inflexible and extended release models. Like, I don't know, we do a sprint that lasts 3 weeks, and you cannot integrate anything until then. We can basically integrate any changes at any time and roll back very, very easily if things go wrong. So this is it. Thank you very much. I am at your disposal on social media and to discuss serverless, to discuss how it affects front-end development, and to discuss how front-end architects are right now a great part of designing these cloud architectures and making decisions in this cloud world. Thank you. I cannot hear you, Neil. I think you're on mute.
Oh, my bad. I was muted. Thank you very much for your time and your session.
You're welcome. Thank you very much, and I hope that it was useful. And again, I hope to stay connected to everyone attending the conference. If you have any questions, please feel free to reach out.
So that was Natalia Vendito on her winner mix for an front-end architecture movie. If you guys have any questions, Natalia, maybe you can share your social media with us.
Yeah,
we can get in touch with you there.
In the
Right. So we have a little bit of an announcement here.
So we have an announcement. So we have how many minutes left? With 15 minutes or so. Rangan is going to be back. Rangan, the guy who did the presentation before on polymorphism, is going to elaborate a bit on C-type. Call in. Yes, Rangan, you're back. Elaborate a bit on C-type. Alright, so Rangan, you have 15 minutes. Yes, Rangan, you're back. Elaborate a bit on C-type. Alright, so you have 15 minutes.
Yes. Can you guys see my screen and all that? Is it okay?
Yes.
Okay. Yep. Let's start it. So this is what we call le retour du comeback. So let me close this guy's face. You only need to see my face. So earlier on, I had to rush in the types class presentation, but some ideas did not go through. So this is to get some of the ideas through. And later on, the guys going to concatenate the two talks together. So when I said about polymorphism and how it was created and what it did, this is what I meant earlier on, what type classes are. Okay, for those who've done C# or Kotlin, you heard about this thing called extension function. Extension function is mostly like a trick. It makes you think that you are attaching function to a type. In fact, it's just a compiler trick where they just reverse the order of the function in the data type. This is what most compilers do when they do extension. Let me go back to the examples. Okay. Now, in the example, I have decided to have 3 operations. And now, string, the data type string, I do not have a hand on it. I cannot modify string. I don't have the source code for string. But I want to have a duplicate method, a toInt method, and I want to be able to have a cat method on it. Because my cat will fight with me if I don't have a method called cat on the string. So, and also, let's say I have another data type coming from another package, something again I do not have control on, like white shark. I don't have the source code, I don't have anything. And I want to add those particular method to that object. If I only have an object white shark, I cannot add method to that object. I can add method to a class using subtyping or through inheritance if the class is open. If it was made final, but also I would not be able to do. So what I want to do with type classes, it allows me to add functionality to a data type that already exists and on which I do not have the hand on. This is a very important concept. So now I've created what we call, here is the contract, also known as a type class, but you have to define on the methods that you want to have, your method to have. And these are called the evidence or instances of your type class. And these concepts are very different from the OOP instances that you have in object-oriented. Okay, here I have a function. It's going to take something of type T, then it expects, then whatever that something is, he wants to call cat on it, he wants to do toInt on it. So to be able to do that in Scala or any other languages like I say Haskell, this thing is passed implicitly. Implicitly means when I call it, like I do it here, I don't put the evidence. There's no need to do that. As long as I know I have an evidence or an instance in scope. In scope means it's in the active space or where that code is running. I can call that method on it. Let's say, for example, I'm doing the white chalk. Let me comment that line. And I have the string. Let's just say I do not want to import the evidence. The compiler says it to me. I'm looking for the evidence. You have not provided me with the evidence. Now, in this simple example, I only pass like one evidence. When you have, let's suppose white chalk itself had over implicit parameters associated to it. What would have happened, the compiler would have filling the blanks. And this is the power of type classes. So all these evidence, as I said before, they are like dictionary entries. And like every dictionary entry, there can only be one entry at a time for one particular instance. What I mean by that, I cannot have another sum operation string in my scope. Here is an example called duplicate. Okay, I create, this is my type class, and these are my instances. This thing I just put it here so that I can do like a extension method kind of a syntax, but you don't have to worry about it. You only have to worry about this is a class definition and these are the instances. Now let's just suppose I have a method called duplicate and has a method called tutu. Now a guy who wants to implement his own tutu in multiply, he wants to multiply a by itself, a by 2. Then there's another guy who just wants to add 2. Now I have method and I want to call print2. Print2 just is the same as the other one. It's something and it expect but to give me an evidence of a duplicate in scope. So I can call that, as you can see, I have addition in scope, the addition implicit instance here, and it can work. No problem. But what if I have both in scope? Now the compiler says, you know what? I have 2 in scope. I don't know which one to choose. Or like if the compiler was a Mauritian, he would say Bulideo, Buendeo. This is how the compiler would say. And this is what the compiler is telling me. So let's do that. Now the compiler is satisfied. Just like you cannot have double duplicate keys in your dictionary, you cannot have duplicate instances of the same data in your scope. Okay, now let's have a look how it's done in C#. In C#. C#, okay, this is a Haskell version. This is a type class for equality. This is just means that I have a function called equal that takes 2 parameters and return me a bool. You can get it here. This is a C# version. Now this is what an interface looks like in C#. And if you look at it seriously, you'd say, what? Apart from the keyword, nothing's changed. Apart from the keywords, nothing's changed here. But while syntactically it's only one keyword, semantically it's not the same thing. Semantically, the interface just said when you define your type as an interface, when you implement an interface, it should be done inside the type. The shape, you put it outside the type. So here's another example from Matt Torgerson, one of the gurus who are like maintaining the C# compiler and the C# language. So you have a shape called S group. S group, for those who want to know, it's like it should not have been called S group. It should have been called a monoid in that case because I have a 0 element in it. So you have a 0 element and you have an operator how to add those elements. Okay, now he's creating an evidence for an int. And this is for the 0, it added, but for the int, it already has a definition, the plus, which is addition. So once it does that, you have already augmented int by S group. Now you can actually do a fold easily on integers. You can do that. Now it doesn't stop here. It doesn't stop here. You can have a bunch of type classes in your scope, and how you can mix and match them is up to you, depending on your business model, your business problem you're trying to solve. Then at the very latest, you can choose to put what evidence you want. And with that, you can have great flexibility. The tremendous amount of flexibility you get on your types, on your program is incredible. As I said, polymorphism gives you flexibility and correctness. Now, not only you get flexibility, you're going to get correctness through the compiler. If you don't provide an evidence on int, the compiler said, no, you know what, you cannot add two semigroup or two monoid together. Those two monoid of int, you can't add them. So this is one of the great powers of ad hoc polymorphism. Not only can you add functionality, you can also add data members, but I don't have enough time to show you that, but you can do that, and you can do that very easily. You can do that very easily. So to continue on my talk, okay, so, okay, as I said, type classes have a definition and instances, and okay, so that you don't need that, and this is the difference between interfaces and classes. This is how you compare and contrast between both of them. I'm going to talk about it early on, and this is me revisiting the slide. And the demo, now the type classes or dictionaries, as I said it, you need to understand that it's like a dictionary being parsed, and the compiler will look for evidence and would just filling the blanks. Anytime it says, oh, you need that evidence. Do I have it in my dictionary? Do I have it in the scope? Yes, I take it, bow. And it works. And your behavior can be done outside your type. And I cannot stress that enough, okay? So in functional programming, it's called the Holy Trinity or the Three Sisters, whatever you want to call it. So there are type classes, generics, also known as parametric polymorphism, hierarchical types, they all work together. I mean, it's like a great family. It's very difficult to break that boundary. And it's over there, it's bread and butter. It's bread and butter. You use that every day. It's very, very comforting for me to see that coming into languages like Kotlin. Scala already had it. Now it's more implemented in Scala 3. C# is going to get it. Go, a language who didn't have parametric polymorphism, is going to have type classes, because we already have something close to interfaces, and parametric polymorphism. So Go is going to be a very, very interesting language to work with in the years to come. Go 2, I mean, not the 1 version. So this is it. So if any of you guys also have questions, you can ask me now. Neil? Neil?
Yes, Rangan, thanks for the presentation. Neil is working on the background to switch. Anybody has any questions? If you might have any question, you can go on Twitter and also directly to Rangan, guys.
Okay.
Good. I will
okay,
see.
Guys, thanks for the 10 minutes plus.
No problem, man.
Okay.
Cool.
One. So you're back for our last session for the day. Can you tell us a bit more?
Yep, we are back for our last session of the day with Joseph. Some of you guys might know him. He was here at around noon, Mauritian time. Now he's going to do the last session of today, which will be on debugging tips and tricks with Visual Studio. Thank you, guys. Joseph, you can proceed.
Thank you. Hi again. Welcome. This time it's still from Phoenix, Arizona. Nice and warm. It's already 95 degrees, which is I think around 28 or so, or 30 Celsius. It's 6 in the morning now, so I'm on 5 hours going straight. But that's enough about me. I'm going to be talking about some tips and tricks in debugging using Visual Studio. My contact information is on your screen. You can reach me at either Hotmail. I'm pretty active on Twitter. You can find out more about me in blog posts like this at my website below, or I stream 3 times a week on Monday, Tuesdays, and Thursdays typically, although I did stream for about 2 hours prior to this, since I had about 3.5, 4 hours to kill between sessions. So that being said, a little bit about me. I'm a director of technology at Quicken Loans. I organize an event similar to this called Desert Code Camp in Phoenix, Arizona. We host about 900 people, usually in October. This year, with everything that's happening, we kind of put that on hold. I am a Microsoft quote-unquote developer services MVP. All that means is I do a lot of work for Microsoft and don't get paid for it. I'm also a Telerik Ninja, recognized by them for helping them out. It's kind of like their internal MVP award. But the more important stat is I am a father of 2 and husband to 1, which means I am always broke and never right. So our agenda for today. Lots of debugging and no more slides. I'll probably pull the slides back up again for the contact information at the end, but for the most part, we're going to spend most of the next 45 minutes inside of Visual Studio. So taking a quick walk through this app. This is probably the world's most complicated application in the world. It is a simple app that just lists out person information. So it has first name, middle initial, last name, email, date of birth, children, and then a function to return what would be the full name, depending on whether or not the middle initial is applied or not. The actual program itself just goes and lists through all the different steps. If we run it, it's going to break right now, so that's kind of the mission. We're going to break the app as we go apart. But before we get started with digging into the app, let's start looking at some of the things that Visual Studio has. Now, your settings might be different than what my settings are, as well as some of the shortcut keys and/or the names. The names should be pretty close. The location might vary depending on how you set up your environment. The keyboard shortcuts will most likely be different unless you chose the Visual C# settings. If you're using VB, settings are slightly different. If you're using F# or one of the resharper settings, keyboard shortcuts are different. I'll try to talk through each step as I use the keyboard shortcuts, but keep an eye in the middle of the screen. There's a plugin that I have that will generate and show you the shortcuts that I'm using. So for the most part, I'm going to spend a good chunk of the time in this debug window. Now you notice that the debug window is relatively small now. As we're running the application, this kind of grows of what's visible, what's not visible. So let's take a walk through what some of these items are, and then we are going to actually do them. First, you'll see the windows. There are 4 main windows that you'll use a lot when you are debugging. The breakpoint window, which we'll see in a little bit, the exception settings, which we might do, we might not do, but that essentially allows you to control which exceptions Visual Studio breaks on and which ones it doesn't. The output window, which you've probably seen many, many times. The show diagnostic tools, which will appear once we're running the app, and then the immediate window, which we are going to use a lot of. So here we have two different windows, start debugging and start without debugging. One is F5 and one is Control F5. So a lot of people always wonder, what's the difference between the two? One of them, like it says, starts the code with debugging. And what that means is Visual Studio is what's called attaching to your program and watching each instruction and syncing it up with the source code. The other says it's just running the app. So you can think about it, if we go and look at our folder in here where everything sits, there is a bin and OBJ folder. The OBJ is a throwback from the C++ days that writes out all the object files that ultimately get combined into your executable. The bin folder is where everything happens. You have two different folders in here, sometimes more, depending on how your application is configured, and we'll walk through that in a little bit. But for the most part, out of the box, the defaults are debug and release. If we navigate into one of them, you'll see a couple of different files. In this case, the mastering debugging.exe, which is the executable name for this. Then the .config, which is the app config for this file. This is actually written in .NET Framework, so it uses the app config versus app settings, but everything else is still the same. Mastering debugging.pdb. PDB stands for Portable Database. If you look at it, it says Program Database. Depending on who you talk to, the name kind of changes, but it used to be called Portable with the portable libraries. Essentially, this is what Microsoft uses, or Visual Studio uses, to debug your application. Then there are these two other sets of programs, same name, but .vshost.exe, .vshost.exe.config, and .vshost.exe.manifest. These are the files that Visual Studio actually runs when you execute your application. It does what's called attaching to it. So VS Host kind of does all the magic behind the scenes of connecting the application with Visual Studio. And I'll show you how we do that in a little bit. The PDB file kind of links all the source code. So you notice here there's no source at all. All the source code is one level, actually two levels up in the folder structure. This PDB file contains essentially a database with the source code. So when you're going line by line in Visual Studio, the application Visual Studio is actually using this database as a reference to display it. And the VS host kind of links all that together. So that is really the difference when you do start debugging and start debugging, or start without debugging. If I just run this, it's going to run the mastering exe without me attaching to it. And the other is start debugging without with the debugging. Another way of doing that is doing the attach to process. You're going to skip over the performance profile and relaunch performance profile because those are only available in certain editions of Visual Studio. The attach to process allows you to connect to any process that is running on your machine natively, and it does this using what's called the Windows debugger. It kind of looks at every exe that's running. As you can see, I have an Amazon Music helper running, application frame host, which is settings. So apparently I have my settings open somewhere. And then 17 copies of Visual or Visual Studio Code insiders, even though I only have one. It just runs so many processes, Docker running, and a bunch of other things. So at any point I can click on this. Let's say I want to debug Microsoft Edge. I can click on it and choose attach, and it will put a debugger attached to it. I won't be able to do much for it because I don't have the source code, but if there's any weird exceptions, I can look into it. This is also helpful if, let's say, you have an app deployed somewhere on your network and someone is complaining about an issue using the Excel spreadsheet generation, or they can't open a file. If they're on the network and the firewall ports are not blocked, you can actually navigate by going to a target. So if you have the user's computer name here, let's say Sally admin, if that's her computer name, you can click find, and then it will go through and list all her applications. So you can actually debug it on that machine without hosting Visual Studio. What else? We're going to cover step over and all these in a second. There's nothing in the, so when I talked about in here where we have a build and release, these are called build configurations. So if you go to the build menu and do configuration manager, this is where you go and edit those settings. So by default, it usually comes with 2. You can create a new one. Typically, you'd have something like UAT, etc. And these allow for certain things to happen. In the old Visual Studio, in .NET Framework, that gives you the ability to have multiple configuration files. Same thing happens with .NET Core. But the key difference is that between build config for debug and build config for release is a set of files is not sent. So if we look at our debug window, we have 6 files sent. The 3 mastering debugging, and then the 3 with the VS host. If you look at the release, we only have 3 of them. It doesn't have the VS host. It still creates that because you can technically debug locally. When you're deploying your application, you should never ever deploy this file because that essentially has your source code in it. You technically can't read it for the most part, but I'm sure there are tools out there that allow you to do that. So let's go about debugging our application. First point in debugging an application is typically creating a breakpoint. A breakpoint signifies to Visual Studio that whenever this line of code is touched, I want you to stop everything and let me know. So there are a couple of different ways to put a breakpoint in here. The most common way is tapping right around the line number, and it's hard to do it because I have all these plugins that are getting in my way, or hit the F9 key, which is what I like. Oh, it's in the column, not in the line number, that's why. So this says as soon as I hit start to stop at that application. So if I click start here or hit F5, you notice this is a drop down that has just the options for start. I can set the release environment, which says I want us to run the release. I'm going to do everything in debug. And then I hit F5 to start it. Visual Studio builds. And now hit this breakpoint. So now on my screen, it's this nice big yellow line that has a feature here, which tells me that the application stopped. So it has this little yellow arrow with the right circle. If I hover over it, I'll see information like program.cs, which is the file I'm in. I'm on line 13 at character 16, so it's all the way to here. You'll notice a couple of other things. I have some plugins on my computer that add some extra stuff, like these icons. You won't necessarily have those. So now while I'm at this breakpoint, there's a couple of different things I can do. I can start and doing what's called stepping. So if you notice up here on my screen, I have a whole bunch of new icons, mostly this bar here, that all have extra things that I can do. The most common ones are these here. And if you're using Visual Studio 2017, these icons changed a little bit in 2019, but we're gonna explain them in a minute. We go to our debug, you notice the window's a lot bigger now, a lot more into play. We have the continue option, which says, okay, continue where you were and keep going until the next breakpoint. Stop debugging pretty much stops us where we are. It kills the application, it doesn't complete running. Detach all means remove the Visual Studio debugger and then let it run. Terminate all just kind of detaches, stops it, and ends the application. Now we have these step backwards, step forward, step into, step over, and step out. We're going to cover these others in a little bit. So let's explain some of them. You'll see that there are icons up here. So step backwards goes back one step before. So since this is the start of the application, it's really not going to go anywhere. Step forward moves it one step forward, so the next line of code forward. Step into, step over, and step out relate to functions. So if we look here, this is a function called populate people, technically a method. So if I want, I can step into it to move the debugger into that function / method, or I can step over it saying execute all that code for me and just get me to the next line, which is line number 15. So if I hit step into or press F11, you notice now my arrow moved and I'm now at line 29, which is inside of this method. And here we are going to create a new instance of the person object, essentially for them, me, my wife, and my 2 children. Now, if I want, I say, oh, I looked at this method, I don't have to worry about it. I can choose the step out, which says execute the rest of the code and come back here. So now that we're here, I can go and I'm just going to do step over and get our next thing. And ignore this little guy for a minute. We're going to come back to him. Now I'm ready to go. I can hit continue and execute the rest of our application. Which stopped at one point. The reason why it stopped is because on line 19 we have a read line, and I did that on purpose because I want you to see what happens next. We're going to get an exception now. So this is what we're going to work on. How do we go and figure out this exception? Well, there are a couple. The main reason for this exception is the argument out of range exception. So if you notice, when we created the people, there were 4 of them. In this code here, the line that failed, which is green, we tried to access the 6th, technically 7th index item in there. It's index item 6, which is the 7th in the array for first name, that didn't exist. So here you get the must be non-negative unless inside a collection. But the reason why I did that is to show a couple different things. We can click on the view details, which shows us, ooh, may want to zoom in full screen on that one. a quick watch window, which kind of shows us everything that's in here. So right now we're looking at the exception. So this tells us everything that's happening within our app, well, almost everything that's happening within our app. Here it tells us the main exception is index out of range exception, and then there's a bunch of properties with it. And you can navigate through all the properties. Here I can see data, I can go look through and see expanding results. You could ignore that, but that's usually used if you're using lists and things like that. The main thing you always want to look for is the inner exception and the message. This is pretty clear what happened. I put in a number larger than I should have. The other thing you can do is, let's say you know about this error and you actually want to try and ignore it. Visual Studio is always going to break on these exceptions. You can open up the exception settings, which appears here, and you can tell it to not stop on these sections. I want to test my code is actually working. So you see here I have a try catch. I want to make sure that the catch is working. In this particular case, it's a generic exception on line 23. So it doesn't really warrant the use case that I'm saying, but at the same time, we can go and look at it. So here's a list of all them. You see that there is a check mark next to system.argument out of range exception, meaning I want you to break whenever that exception is thrown. If I uncheck this, it's no longer here that this checkbox became unchecked. So if I click it again, now this checkbox is checked, or vice versa. And I could also do it only from this application. So if I want to validate it here, now I'm going to stop the application and restart it. I hit play, and we have our breakpoint there. Hit continue, hit enter, and it's done because there's no corresponding console.write line. So it came here and wrote out the exception. So what I really should do here is put a console.read line, which indicates that it worked. So I hit start and I hit continue. As soon as I hit enter, we get our argument failed. Hit enter again, the app ends and goes away. So that's a good way of showing us how to do that. And you can get that at any time by going to debug, Windows, exception settings, and I want to remove that condition because I don't want to forget that I had it on there. So that's the first part. So we looked at how we can create a breakpoint and how we can step in, step out, but you can do more than just create the breakpoints. You can actually label the breakpoints and hit conditions with them. So I'm going to take out this breakpoint and I'm going to add another one here. This one, I want to figure out why. Now let's comment out this now so we know that that's going to break. Let's say we want to break on the user Emily. For some reason, she's causing trouble. And if you know my daughter, you know that she's causing trouble. But she's all the way at the end of this list. I don't want to have to keep hitting continue, continue, continue 4 times to get to her. I'd rather Visual Studio be smart enough to get to it. And if you can imagine having a record set where you're going through 5,000 records and you know it fails at record 4,990, hitting F5 to continue 4,990 times would be a pain. So here, if I hover over this, you'll notice that there are 2 buttons, settings and disable. disable keeps the breakpoint there, but it doesn't actually break on it. That allows you to keep a history of the breakpoints and only turn them on when you need it. The other is the settings, which populates here. This allows us to create conditions and actions. So I'm going to create a condition. The condition is very similar to a Boolean expression. You can do hit counts, filters, or conditional expression. Hit count would be used, how many times has this piece of code executed? In our current example, I can do 4 to get it to break on Emily's name, or I can do a conditional breakpoint and say when it's true, I want person, you see I get IntelliSense with it, person dot first name equals to Emily. And then I can also add actions to it if I wanted to. I can send a message out there and just stop. So this says, maybe I just want to know what her ID is or what her email address is. This allows me to do that. I'm not going to set the action right now. You'll notice now that over here, it's now changed to a plus sign, which tells me that there's a condition in there. So if I hit start, it's going to, you can't see because the window disappeared so quickly, only print the first 3 names, me, my wife, and my son, who are the first 3 in the list. As you can see, me, my wife, and son. And Emily stopped. Now, if we look at Emily, oh, I forgot to, if we look, we can see details about Emily, but how do we go about seeing those details? If you click over the person, you can expand on it. Ooh, I want to break because I have something highlighted that I shouldn't have highlighted yet. Now, if I hover over person, I'm going to get a mastering debugging.person. I can open it up and then see details about Emily. I can see she has no children. Her date of birth was 5/31/1999. Her email address is this, first name is that, etc. And her full name is that. You notice there's a little magnifying glass here, excuse me, with a drop-down list. This allows for what's called visualizers. By default, it's smart enough to detect what kind of visualizers that is. And what that does is kind of displays it in the IDE differently. So if I just click on that, it's going to display as a text with just this text box. But if this was a JSON document, let's say, and I did this to JSON, it's going to try to visualize it in JSON and tell me that the value is not a valid JSON document. You also notice that everything is in quotes in here. This gives me the ability to actually change a value. So I can call her Emmy, which is what I call her from time to time, hit enter, and it updates the value in that object to Emmy. As you notice, the full name property changed because it realized that there was a change to the first name. If we go look at the person object, the full name takes the first name and last name if the middle initial is null. If the middle initial is not null, it builds out first name space, middle name period, and then last name. This, however, does not change the object that this came from a database. It does not update the corresponding database. It just updates the value for it in in memory right now. So if this was actually pulling from a database, and let's say line 18, I saved it, it would then save the new value, which is Emmy. Well, that's up. We're going to look at another thing that we can do called data tips. So if you noticed here, I hover over it, I get this little person display. There's a little magnifying pin right here, which might be hard to see. Let's see if I can, if I zoom in on it, it might show, yeah, there it goes. There's a pin there. If I hover over it and hit the pin, it creates what's called a data tip. This data tip now shows every time we're in here, and I can open it up and I can pin something. So I can pin her name. Now if we restart the application, so I'm gonna hit play, start again, you'll see that that value is there. If I hit a breakpoint here, let's say I wanted to start over, I can come back here and choose, where is it? Set next statement, which pulls us all the way back to here to re-execute those lines of code. And if you see here, this is now grayed out the cache value or the value from the last session. So if I hit function 10, or I actually hit function 11, which is not what I wanted to do. So let's hit function 10. Hit function 10 again. And now if I break point for each one of these, you'll notice as soon as that person value changes, it's saying red because the value is different. Now I run it and it's telling me that the person dot full name was different from the last value. That's why it's showing up as red right now. Hit it again, it's gray because that's the last value. Step through it, it's turning red because it's saying that, hey, there's a change coming. Hit that, and we now have a new value. These are cool too because you can kind of move them around. I can click and drag and move that. I tend to put them like right next to where they are. You can also expand them and add a comment to it saying, you know, displaying the first name or displaying the full name. This is if you want to see that there's a problem. But the real value is not for you to see the full name. The real value comes in that you have the ability to export these. So you can go to debug and export data tips. And this will allow you to create an XML file that anyone with this solution can re-upload and have those same data points. So think about it in that previous example I gave with the 5,000 records. Let's say you were trying to figure out an issue with record 4,990, and you're about to go on vacation or holiday. You can set these breakpoints, hand it off to the other developer that's covering for you, said, here's everything I got, here are the data tips that I was using to help me figure out that problem, which is a neat little feature. Cool thing is you can do the same thing with breakpoints too. So we go here, we can do toggle breakpoints, new breakpoints, which we've seen, but if we go to Windows, there's a lot more windows now than there were before. We have our breakpoint window exception. So these four were here before, but now we have task, parallel, parallel watch. We're going to walk into the watch, autos, local, and immediate now. The others are really dependent on what you're doing. Task, parallels, and parallels watch. These are if you're using the parallel task library or asynchronous async code. This allows you to debug those. Skip over these for now. We're going to show you in a minute. DOM Explorer, if you're debugging a web application, this will show you the document object model. Live Visual Tree, Live Property Explorer, these are for WPF applications. Call stack will show you in a couple minutes. There's a bunch of windows on the bottom. Modules really don't use, this is more for C++. IntelliTrace is beyond the scope of this. This is only available in the enterprise editions of Visual Studio, so I typically don't cover it. Processes will show you any running processes on the machine that's similar to the attach. The next three are for assembly language code. So let's view our breakpoints window for a second. So you see this lists out every breakpoint we have in the application. Right now it says we have a conditional one in program.cs on line 17, character 21, which is right here. That says when person.entity equals Emily is true, break. Hit count currently 1 means it's the first time it's actually encountered this, because there's only one person named Emily in this list. I can create new breakpoints here by doing a function data point, and this is really hard. You actually have to know the syntax for it, and I only know because I'm looking at it right now and typing it, and I think this would be 16. I didn't get the syntax right. That's why it's there. Let's see what it says. I was off by 1 character. So you can manually type it if you want, but I never recommend doing that. You can delete any breakpoint from here. If you uncheck it, that does the disable that we talked about before. This will delete all breakpoints that meet the conditions. That's everything in here, although I can narrow it down to only say line 19. It's only showing this because there's only one project. If I did something like this here and did a breakpoint on that, I can narrow down the search to anything that has the word first name in it or anything with program, whatever I want. So anything in the window I can delete. Export and import is the same as the data points. I can export all my breakpoints from here and share them with the developer. This looks like the same as the data tips. It'll give me an XML file that I can then go and share with others. So that's enough with breakpoints for a little bit. While the application is stopped, let's look at a couple of neat little things. There's a bunch of windows on the bottom that I have open. The first is the error list, which unfortunately every developer is familiar with. This is where you have all your build errors. Output shows us the output. That's from the build output. You can see different output windows here. Lots of different applications can write to here. In this case, I'm highlighting the Git provider writes output to here. But for the most part, I don't use that window at all. The immediate window allows you to execute code in your browser or check for variables. So I can do person.firstname, and it'll tell me what the current person's first name is. In this case, it's Deirdre. But really no one ever calls her that, so I can actually go in the immediate window and change that. So I can set her first name to D, which is what everyone calls her. And you notice once I did that, it went and changed here. So we open up the person, we have the person D, and the first name changed because that was different from the previous value. Even if I change it back and do person dot first name equals DEIDRE, it's still going to be red because it's a change from the previous version. And you can do pretty much anything in here with the exception of some link statements. So I can go and add to this list. I can do people.add new person. I won't do that because that's going to throw an exception because we're inside of the for loop now. But you get the drift. I can do almost anything. Call stack shows us where we are in the application. So I'm going to stop this for a second and then play it with the breakpoint that, oops, I removed the other breakpoint. I'm going to stop it for a second. I'm going to add a breakpoint here. Now, if I look at the call stack, you see there are two items in here. There's populate people, line 31, which is where I am now, and then submain. I just noticed that my class name is spelled wrong. Huh. I have to fix that. Submain, which is where it came from. So it says, essentially, we got to line 31 and populate people from the main method line 13. So if we double click on that, you'll see it gives us a light green that tells us this is where we came from. The icon also looks a little bit different in the screen. There is a little, where'd you go? There's a green arrow that says we're kind of stepping into this. That little blue push pin is because we have something pinned right here. So that's the call stack. It lets you see where you are. I'm going to continue and talk about the locals window and the watch window. Well, I get a drink since I'm getting very dry. The local windows in Visual Studio tries to give you all the relevant variables that are in scope for your application at the point in time that the code is running. So here on line 17, it knows that I have access to the people, person, and the args, since that's the only items that are available to me. So I have all the same ability that I had before. I can go see a person, I can list them all, I can go and change Emily's name to Stinky because that's the other name we call her, and then it updates it the same way everywhere else. What I mean by the scope is, let's say I created a variable here called var first name equals person dot first name, and we're not going to use that variable in here, and let's just take off that for now. Click start. Now if I look at the variables now, I see first name in here. When I navigate away from this, let's do a step over. Now you'll notice person and people are no longer there because they're no longer in scope. This line that we're on right now, line 20, doesn't have access to a person anymore or the first name. It only has access to people and arguments. Now the watch window is super similar, except difference is with the watch window is you can put in what variables you want to know about. So if we restart our application, which is this little button here, I say I want you to always tell me the person first name, person email address, and person last name. I can also add anything else. Since I got the first name field now, I can add the first name. And that gives me the ability to see whatever I want. And just like the other places, I can go and change this anywhere I want. The last thing I want to share with you while we have a couple minutes is you notice if we are in the person, when I hover over the person, I get this long, boring mastering debugging .person. And then I have to go and open up and click on it to see each thing and then potentially pin whatever values I want. That's kind of a pain. There is something called the debugger display attribute, which allows you to customize what is displayed here. So I'm going to click stop. And then I kind of hinted to this before because I had it running. If we enable this debugger display attribute, which is in the system diagnostics class, you can use string interpolation to control what's displayed in here. So I can do full name, and I should have IntelliSense. I don't know why it's not showing. And saying date of birth, I only want to show the minute, the number of children they have, and the children.count. So now if I hit play, now you notice when I hover over a person or look at the person, I get the fully qualified list. In this particular case, the number of children for Emily is a null entity, meaning it's not set. That list is not set because she doesn't have any. But Visual Studio doesn't destroy your application or doesn't break it. It just tells you that there's a problem. And we can verify that by removing the conditional breakpoint and looking at myself. So now you see that I have one child listed, even though it technically should be two, so I got to figure out why that's happening. And my time of birth and everything else. So this is a really handy tip to get you through some debugging. And that's all I have for you now. If you have any questions, feel free to reach out. My contact information is here. If you are interested in learning more about that debugger display attribute, check out my website here and search for debugger display, and you'll get a whole article around that. That being said, that's all I got, and just in time too. I'm done, so that's good.
Thank you very much, Joseph.
Thanks, Joseph. So we haven't got any question on YouTube, but I wanted to ask you a few things. Is you or an organizer at this podcast? Can you tell us a bit more about this and how can a Mauritian participate? Is it available online?
Right now, Desert Code Camp is a in-person event. We host it usually in October. This year we canceled it because of COVID and not wanting any in-person events. Similar reason why you guys are virtual. We haven't done any streaming or any live broadcasts of it in the past. But that might change in the future as we get more towards online conferences. We just didn't have enough time to put something together to enable us to do that. But it happens here in Phoenix, Arizona, United States.
Okay, good. And yeah, I think. Do you have any questions, Neil?
Nope, unfortunately, but it was a very interesting session. Someone who uses Visual Studio and definitely learned a lot. Thanks.
Yeah, and you can also check Joseph's stream on Twitch. I will share it on Twitter. And here.
Thank you guys. Have a great night. Well done.
Thank you. Have a great day.
Bye bye.
Bye bye. So, yes. So we're still online here. We will wrap up this session.
Yes, you are still live.
Okay, so thank you guys for tuning in. You have been following since this morning on the Avengers Tower. Brought to you by your two hosts, me, myself, and I, Stesham, my friend Owen is there. And yeah, in the beginning there was some audio issues. I think at the end, Vina told us there was some, a couple of times there have been some muted audio. Sorry about that, and also the echo. We'll try to learn from this technical issue. We'll do a briefing with Neil, and so that tomorrow we don't get these kinds of things. So just a quick reminder, today was, most of the talks were based on Kubernetes. Tomorrow we have, it will be on AI, mostly. On AI, a bit of blockchain, and what, yeah. Mostly AI, a bit of blockchains, and a couple of things as Scrum by my friend Nirvan. Yeah, Christian saying, thanks guys, catch you up tomorrow. Great, Christian, see you tomorrow. So we are wrapping up, it's nearly 6 now. Conference, day 1 is over. See you tomorrow guys, have fun.
Thank you everyone, see you tomorrow.
There is a core belief at the heart of Liquid Telecom. The belief that every individual has the right to be connected. The pursuit of this vision has seen us build the largest independent fiber network in Africa. From Cape to Cairo, we are connecting more of Africa. Liquid Telecom, building Africa's digital future.
21C Skills is our learning platform which we've designed to help Africa's students, startups and developers gain skills that they need to succeed in the technology age in the 21st century. 21C Skills has been built for the African tech enthusiast.
It's about empowering kids to get the necessary skills to compete at a global level. Let them use their imagination to create their own companies, to work for other companies, to be part of the gig economy, etc.
21C Skills for me means eyesight. You got to have very qualified people train us through video, and we also got to have highly interactive labs that challenged me.
Take the 21C Skills program, put a lot of work in it and time in it, and it does pay off.
We're SD Worx. Nous sommes SD Worx.
Teamonite.
To disrupt is to disturb. To disturb is to unsettle. To unsettle is to dislodge. To dislodge is to challenge. To challenge is to reshape. To reshape is to play. To play is to create. To create is to invent. To invent is to innovate. To innovate is to succeed. We caught up with Managing Director Michael Shapiro and asked him in 120 seconds or less to tell us all we needed to know about synthesis software technologies. It helped that he was on a treadmill.
Who is Synthesis? Let me tell you in 120 seconds, starting now. Synthesis is your ultimate technology partner. We live and breathe innovation. If you're looking for us, don't look anywhere near the box because we're so far out of it that we hardly remember what it looks like. We haven't forgotten that technology is all about people. Our team is our family, and we live by the adage that culture eats strategy for breakfast. We employ over 150 people. We have offices in Melrose Arch and Sandton, and an office at the foot of Table Mountain in Cape Town. Our tickets are booked for Mauritius, and as soon as COVID allows, we'll be set up on the island. True story. Our focus areas are intelligent data, cloud, academy, labs, regtech, digital, MSP, payments and crypto. Our technology partners include AWS, Confluent, Cloudflare, HashiCorp, VMware, Thales, and soon to be announced, Salesforce. Our client base includes enterprise in the financial services, retail and healthcare sector. We are proud to stand alongside South African banks as their technology partner, to name a few: ABSA, AFGRI, Afrasia, Capitec, Discovery, Investec, Nedbank, Sasfin, Standard Bank, and Woolworths Financial Services, done in alphabetical order, not to offend. Our growth rate is 25% every year for the past 15 years. We launched the data science and engineering practice based on machine learning and AI principles. Our payments and crypto area is providing a world-first technology with Halo. Our MSP team stays up all night so that our customers can sleep peacefully, knowing their support is in good hands. We're on track to become an AWS Premier Partner, fingers crossed. We're proud to give back to South Africa and work with partners, Africa Ticket and Girl Code, and run a hackathon with gender-based violence. To define us is to lose the essence of who we are. We believe in our people, we believe in our clients and their business. In 120 seconds, that is Synthesis.
Synthesis Software Technologies always gives you more. That's who we are in 127 seconds on a treadmill.